Good morning, everyone. Welcome to the 9th Haifa Conference of Marine Sciences. My name is Debbie Ramon. I am a PhD student here at the School of Marine Sciences, and I'm part of the organization committee. This is a very special conference as it is on the same week as the 50th anniversary of the University of Haifa, as well as the same week of the governor's meeting. Thank you to our distinguished guests, Dr. Vladimir Ryabin, Minister of Environmental Protection Tamar Zandberg, Mr. Nachshon Zook, Tzili Charny, Professor Amy Clement, Professor Kenny Broad, researchers, students, NGOs, industries, concerned citizens, and also to our volunteers. Thank you for being here, from joining us from here in person, near, far, and virtually. We would like to take a moment to pay tribute to our dear friend, Ziggy Livnat, who passed away suddenly last week. Ziggy dedicated his life advocating for the ocean and was constantly giving it a voice when those around would not listen. Today's conference is dedicated in his memory. The annual event was started by the Leon H. Charney School of Marine Sciences in 2013, with each conference focusing on a different theme related to ocean. Our conference today is organized by students of the Charney School, and it was decided that the theme of today would be a topic on one of the major obstacles of our time: climate change. University of Haifa has many different departments and researchers who focus solely on understanding what's the issues around climate change. We hear and talk about climate change often. It seems like in this day and age, it's all we ever talk about. However, oftentimes, climate change and the relation to our ocean is overlooked. All right. Okay. Thank you. Though it is the ocean that has protected us and acted as the buffer to its full effects. And while the ocean has done a tremendous job at lessening the blow, it has come at a major price to ocean health. The ocean is so important that the United Nations has proclaimed this decade as the Ocean Decade, the science we need for the ocean we want. This decade of ocean science for sustainable development aims to support efforts to reverse the cycle of decline of ocean health and gather ocean stakeholders worldwide behind a common framework that will ensure ocean science can fully support countries in creating improved conditions for sustainable development of the oceans. The 7 outcomes described in the ocean we want is a clean ocean, a healthy and a resilient ocean, a productive one, a predicted ocean, a safe ocean, an accessible ocean, and an inspiring and engaging ocean. You may have already noticed, but our Climate Ocean Change Conference is not your typical academic conference. Academic conferences are a wealth of information, yet oftentimes this information never reaches the public. As researchers, we felt that it was our responsibility to create a day where we could gather individuals of many backgrounds together, and where the knowledge gathered here would reach the community. Today's conference is broken down into 3 major topics: the problem, the evidence, and the solutions. We have brought together ocean advocates from many different fields, from academia to the private sector to the general public, in the hopes that together we can advocate for a positive change that will preserve the ocean and benefit for all future generations. I'd like to invite onto the screen Dr. Vladimir Ryabin, an oceanographer, climatologist, marine engineer, and is currently the Executive Secretary of the Intergovernmental Oceanographic Commission of UNESCO, as well as the Assistant Director General of UNESCO. Please.
Madam Chair, Your Excellency Tamar Zandberg, Minister of Environmental Protection of Israel, Mr. Nachshon Zook, Deputy Mayor of Haifa, Professor Ilyana Berman-Frank, Head of the Charney School of Marine Sciences at the University of Haifa, ladies and gentlemen, all courtesies observed. I'm delighted to be with you today to participate in the opening of the 9th Haifa Conference in Marine Sciences, focused on interconnections between ocean and Madam Chair, Your Excellency Tamar Zandberg, Minister of Environmental Protection of Israel, Mr. Nachson Zook, Deputy Mayor of
In the meantime, while we deal with technical difficulties, I'd like to invite to the stage Mr. Nachshon Zook, who is the Deputy Mayor of Haifa.
Good morning, dignitaries, guests, and faculty, and everybody. Actually, have my speech in Hebrew, but I need to make an online quick translation as we go. I hope it will be successful. As part, my main portfolio is the portfolio of the sea, which was never in Haifa. Haifa never had anybody that dealt with the sea at large, and Haifa is, as you know, is the major port. I'll talk a bit later about it. But at the moment, about, I would say, 6-7 miles north of here, there is a grain ship that arrived here about 2 weeks ago from Turkey. She was on her way to the Ukraine with to the Black Sea with a cargo of grain, but it has some kind of disease in the holds, some kind of measles. And Turkey, that's the name, just expelled her, and then she went to Egypt and expelled from here, and she's an anchor here for about 2 weeks. We don't know what's going to happen. So we see that we're in the center of everything is back to the maritime arena. And that was not very well known in Israel for the last, I would say, 75 years since the formation of the state. And it's raising. The awareness is raising in the country and in the city. And of course, being a part of the Mediterranean and the Black Sea, we see everything is rather close. Odessa is the next target, I guess, for the big fight in Ukraine. And the idea is as it was 500 years ago in the age of Vasco da Gama and Magellan, is who controls the sea. And we see the Moskva sank, and Russia cannot enter new warships into the Black Sea because of a very old agreement, and 10 countries have to sign every warship that goes into the Black Sea, including Australia, for example, because it's quite an old agreement. So everything around us here in Haifa, in the Mediterranean, in the Black Sea, in Ukraine, is about who controls the sea and resources. So it's not just conservation, as we'd like to talk lately, but it's also back. We understand now that we're back 500 years ago and fighting about the sea. The South China Sea was the U.S. and China, of course, and we have the gas resources and all the new ships that the Navy bought to defend it. And of course, all the commercial stuff like the Belt and Road Initiative in Haifa with the Chinese port, in Athens, in Venice lately in the last 3 years, which is the gateway to the whole railroad in all of Europe. And we see, as a result of the COVID epidemic, the rise of marine transportation, which quadrupled or even more in some places, and things are stuck all over the place. Nobody knows how to solve it, and the only way to solve such problems on top of diplomacy is, of course, technology. So what do we have in Haifa? We have in Haifa two main assets. We have 5 ports. We have 3 research institutes. We have everything here. We have 2 high-tech institutes, Haifa and Haifa University and the Technion, of course. We have the biggest Navy base in Israel. And the marine superstructure or infrastructure and technology is what we have here in Haifa, and that's our main issue in the municipality. And the country is getting to understand that the sea is the main resource, our main resource, because the sea area of the country is 10 or 15% larger than the land itself. So we in the municipality got recommendation and actually approval from an intergovernmental committee that Haifa is going to be the next, how they call it, National Center of Blue Technology and Blue Economy. We have not waited much. We raised our own money. We don't wait for money from the government, and the center is in final stages of being formed. Lior is here. He's the manager of the high-tech company of the city, and this is going to be a branch in that high-tech company. And we currently have a place. We are getting people. The tender for people who runs this business is finalizing in these days. So Haifa is going to be the center of Israel. That's by a government decree of blue technology and blue economy. To our own delight, of course, the city, municipality, the mayor, and me are most delighted to have this, and I tend to it as part of my portfolio of the sea. And all this is going to happen very close to the campus in downtown Haifa, in the port quarter, and we hope we find also a place for the maritime school in the near future, and I am updated there are quite steps forward with this. I don't know if it's finalized, but we have different ideas. And of course, all the information center is going to be there, and the city high-tech quarter, okay? What is called in Hebrew, Rova Chadshanud, I don't know how they call it, the innovation district. Okay, that's the name. So all of this comes together in downtown near the port with support of government, with support of the municipality. And we are going to start it. We're going to kickstart it in a big conference that we're going to have on the 4th of July in the Baha'i Gardens with their hospitality. And I hope you all join us over there. It's going to be an international conference, big one. You're most invited. And Haifa is going to be the city, the hub of all the efforts of the country in maritime, blue economy, and blue technology. I hope we are successful in that venture. Thank you.
Next, I would like to invite Professor Ilana Berman-Frank, who is the head of the School of Marine Sciences.
Good morning, everyone, and I'm really happy to see you here. And we will get over the technical difficulties and have our virtual speakers on in a minute after I speak. So I'm pleased to welcome the virtually the Executive Secretary of IOC UNESCO, our Minister of Environmental Protection, Deputy Mayor, Ms. Tsili Charney, distinguished guests. It's an honor and a pleasure to welcome you here, and I will be brief. I'm happy to welcome you to the 9th year of an already established tradition between the city of Haifa and the University of Haifa, Leon Charney School of Marine Sciences. The overarching aim of these conferences is to hold a public and academic discourse exposing cutting-edge research on important issues related to our marine environment, the increasing pressures on marine resources, and the essential requirement of maintaining a sustainable ecosystem for future generations. This year, the conference entitled Climate Ocean Change touches on a crucial topic that has wide-ranging implications from our local to global environments and communities. The Mediterranean Sea, especially the Eastern Mediterranean region, is also one of the most sensitive and responsive areas to climate change, with increasing global temperatures affecting both surface and deep water temperatures and impacting this blue desert, affected greatly by other human activities, all contributing to the greater human footprint in coastal and offshore areas. Our Mediterranean and global oceanic lifeline needs to be maintained for the future by responsive development and conservation of marine resources. These aims are the core of our activities at the Leon Charney School of Marine Science at the University of Haifa. And I'm especially proud this year that the conference was organized by our students who are our future. And our students have taken upon themselves the challenge to showcase and highlight the issues confronting us related to climate and ocean change. I would like to thank the students' organizing scientific committee who worked hard to provide a tantalizing conference, and especially a big thank you to our student chairs, Debbie and Alyssa, Akos, and to Rotem Dorwey, who is in charge of all of the logistics, and who worked very, very hard to make sure we are all here today. I wish you all a productive and enjoyable meeting. Thank you. And I was just informed that we need to take, the technical people are going to try to solve the sound issue, so just stay in here for 2 minutes and hopefully this will be resolved. Thank you.
United Nations system is a unique space because it embraces elements of this value chain, all elements. It leads the development of groundbreaking science on oceanification, deoxygenation, harmful algal blooms, tsunamis, and much more. Under the IOC leadership, the Global Ocean Observing System provides a robust infrastructure to coordinate national and international systems observing essential variables in oceans physics, biogeochemistry, biology, ecology. The IOC International Ocean Data Information Exchange Program, a global network comprising 100 data and research centers units, ensures open access to this key data and information for all member states, reinforcing capabilities to use data to inform ocean management and decision-making. All these programs involve academic communities like the one gathered here today. Scientists, experts, students work together across borders and, in spite of an increasingly polarized world, deliver the science we need for the ocean we want. From climate to the sustainable ocean economy, the ocean is a source of solutions for meeting the United Nations 2030 agenda and its sustainable development goals. The ocean is securing the livelihoods of over 3 billion people, and with the ocean economy currently estimated to hold the value of $3 trillion by 2030 every year. Unlocking these ocean solutions requires a knowledge revolution. At the cutting edge, an example here would be the new global environmental DNA initiatives, and also coming from the roots of traditional and indigenous knowledge. We need to rethink how we, as an international community, generate and use ocean science to respond to major challenges of our time. This is the critical mission of the United Nations Decade of Ocean Science for Sustainable Development 2021-2030. The Ocean Decade is a once-in-a-lifetime opportunity to fill knowledge gaps about the ocean and build strong bridges between science and policy-oriented solutions to address pressing societal needs. Leadership of the Ocean Decade implementation is a major contribution by UNESCO in its Intergovernmental Oceanographic Commission to global sustainable development efforts, and I'm very happy to see how strongly the scientific community has engaged in the support of the Ocean Decade and also its endorsed actions. In its second year of implementation, the Ocean Decade is in full motion. It is now the largest undertaking in the history of ocean sciences ever. Over 160 endorsed Ocean Decade actions are working on transformative ocean science solutions in every ocean basin across the world. The decade has reinforced ocean science priority setting and coordination around the world through 7 regional task forces. And to date, we have 28 national decade committees in different countries. The movement of the decade will keep growing, and the next major opportunity for uniting for the action is just a week away. After a very successful first convening in 2017, the 2022 United Nations Ocean Conference will be held in Lisbon. It is hosted by Kenya and Portugal, and the conference will bring the international community together for the most important ocean summit in 5 years. UNESCO, the whole United Nations system, thousands of experts from around the world, across government, philanthropy, civil society, the private sector, not to mention billions of concerned citizens, are looking to academia, to research communities for guidance on how to conserve and sustainably manage this blue planet. I am confident that through your collective strengths, the ocean science community will rise to the occasion, opening our society and the ocean to a healthier and ever so symbiotic relationship. I wish you a very productive conference, fruitful exchanges, great ideas, and I look forward to following these proceedings. Thank you so much.
So we have a second video that is by Knesset member Tamar Zandberg, the Minister of Environmental Protection. For scheduling reasons, we will show this video at the end of session 1. So for the moment, we will move on in the program. And in order for us to begin to have the conversation about climate change in the oceans, we first need to understand what the problem is. So in this first session of the conference, we would like to address the problem at hand and provide an overview of climate change and its connection to the oceans. We'll begin with Dr. Beverly Goodman-Chernoff, a marine geoarchaeologist who studies how the archaeology, geology, and anthropology of marine systems can help us understand the impacts that natural processes and human activities have on coastlines. She is the head of the University of Haifa's Department of Marine Geosciences, as well as a National Geographic explorer. She's been featured on numerous television programs, including shows on the History Channel, the Discovery Channel, and National Geographic, and her work has contributed to tsunami disaster planning and education in Israel and in the Eastern Mediterranean. Welcome, Beverly.
Good morning. You didn't know you were at our dress rehearsal, did you? Thank you for coming. Could you go ahead and put the presentation up?
Which one is yours?
Okay, so before we begin with our keynote speaker today, I would like to do a little bit of an introduction for climate, ocean, and change for the Eastern Mediterranean. This session is called The Problem, so we're going to talk about just to go over some really basic information about the problem. So if we, it's not advancing, hold on. It's not advancing. Is it only from here? Okay, here we go. All right. So what are some of the basic facts that we hear about, and what some of the things that are understood and accepted and well established are that we can anticipate over the next 2 decades about a 1.5 degree increase in global temperatures. In addition to that, in the last 7 years, we have seen the warmest years on record. And in general, since 1870, sea level has risen worldwide on an overall of about 8 inches. But it's important to remember that this isn't distributed evenly, so we're talking about areas that are disproportionately affected. If we go and look at how this affects our region, what we can see is that considering what has been input to the planet in terms of carbon dioxide, we should actually be in a worse space than we really are. But fortunately, we have the ocean, and we're on a planet that is 70% water. So one of the major roles of the ocean is to actually sequester this heat, to take on this heat. And that's one of the major things that we want to talk about today, and how these two things interrelate. So I did promise that we were going to speak locally for a moment about what's happening in the Mediterranean and how we're special. Well, the Mediterranean is really unique, and these issues that we're dealing with are especially acute here because of a few factors. One of them is that the Mediterranean has very slow circulation, meaning that the replacement of the water, the refreshment of the water in the Mediterranean is slower than many other areas of the world because of the way that it's semi-enclosed and the nature of the currents within the Mediterranean. It also has higher salinity than other marine water bodies, and it has above the global averages in terms of sea surface temperatures. So in terms of all of these things that we're talking about globally, the Mediterranean can arguably be one of the more extreme examples of this. So for example, if we look at the heat map for what we see, you'll notice that the hottest temperatures are in the far eastern Mediterranean. We can also see that in terms of the increasing temperatures in general over the past 20 years, the Mediterranean is following that trend very clearly. And we also have issues of where all of this heating is causing evaporation, is causing drying in areas around the region of the Mediterranean, which is reason for concern because of agriculture and drinking water and all of these other concerns, which we've semi-solved in our region using desalination. But if we use desalination of water, we of course have to also be protective of the water that's being processed for drinking water. Okay. In order to understand this, we have to gather information, and then that information can be used for models. We need to understand how quickly things are heating, also where are these different effects, how is this going to go into the future. And one of the things that we're seeing with this warming is that it changes the water column. The temperatures going to depth are not all the same. You have warming surfaces, and then you have changing temperatures going down. And as we get warmer and warmer temperatures on the surface, we tend to get less and less mixing, leading to what they're calling tropical seas. Okay, the Mediterranean is looking more and more like tropical seas, where you have higher temperatures, you have lower nutrient values, and of course, that's a whole changing environment. Now, In addition to that, we of course have organisms that are coming through the Suez Canal, and they're finding these seas that are becoming tropical. And so that is also contributing to the changing biodiversity, the changing organisms that we're seeing within the Mediterranean. In addition to that, as monitoring programs from the Charney School and from other parts of the Mediterranean are noticing that there are these changing species and that we are seeing a different sea developing because of all of these issues. In addition to that, we also have the Aswan Dam, which has reduced the amount of nutrients and sediments that's entering into the Mediterranean. So again, we have this layered effect of natural and man-made issues. Okay, so now that we kind of have a little bit of a picture of what's happening in the Eastern Mediterranean, I hope. Okay, so I will go on without the presentation. What we're going to try to do, what we'd like to do is, no, okay, it's okay, it's okay. One of the issues that we have is we get all of this information, we have all of this data, and then somebody has to come along and do something with it. Somebody has to be able to understand how do you take this information and make these predictions, create these models. So I'm really excited today that we've invited Professor Amy Clement of the University of Miami, Rosenstiel School of Marine and Atmospheric Sciences. She is a real trailblazer in terms of understanding the importance of looking at paleoclimate, looking at records that are coming from the past, as well as looking at these data sets from today to better understand what these climate effects, how the ocean is interacting, and how we can use that to model what's going forward. She has been a major role since 2001 developing an incredible research group that is not afraid of going down dark alleys to look at information that other people are saying, this is a dead end, this isn't going to be very helpful. And she's really a risk taker and a very creative thinker and really willing to make mistakes and to fumble in the effort of trying to find some real information. In science, and as people, as human beings, we love to have simple answers. We like things to be very clean and very black and white, and this leads to that. And I think that one of the most impressive things about Professor Clement is the fact that she recognizes that it's never that clean. And because of that, she's been able to introduce the relevance of different climate systems, including tropical systems that were previously disregarded, and how these interactions happen in a way that give us the opportunity to be better prepared and have better models. And she continues to be proven right. So with that, I'd like to introduce our keynote speaker, Professor Amy Clement. Thank you for coming.
Morning, everyone. Or I think it's morning. We just flew in last night from Miami, so a little disoriented time-wise, but all right. While this is getting set up, let me just thank you all so much for inviting myself and my husband, Kenny Broad, who you'll hear from later. I was here in Israel. That one, Clement. In 1999, when I had just finished my PhD, and I was here for a seminar at the Weizmann Institute. Actually, was here in Haifa visiting with a colleague of mine who was at the Technion on sabbatical, and so I spent a really, really lovely time here in Israel and gave talks at the Weizmann Institute and at the Hebrew University. So it's really fun to be back. Thank you. And thanks, Bev and Rotem and Ilana and everyone for hosting us. Okay, so some slides. I'll just start talking. Maybe should I? We're good. Okay, good. So let's see. Yeah. This is the end of my talk. Hold on. Let me go back to the beginning. Okay, there we go. All right, so this talk is about predicting the future. As Bev mentioned, I've been engaged in this field for several decades, trying to build models in order to make predictions about the future. And I'm going to dive into some of both the atmospheric processes and the ocean processes that are important, ending up with talking not only about how we as humans are influencing the ocean, but then in turn how the ocean influences the atmosphere, which then influences the climate that we experience over land. So first I'm going to start mostly talking about the successes we've had with atmospheric modeling without actually having to worry too much about what's happening in the ocean. And then we'll move on to our present challenge in order to understand how is the ocean, what is its role in predicting the future. Okay, so I'm going to first take you back to a time when predicting the future was just a fantasy. This is a rendering of this fantasy by Louis Richardson, who was an English physicist who first hypothesized that it would be possible to predict the weather by using the basic physical laws that govern atmospheric flow. So this was just actually a concept, just a hypothesis, and he envisioned this forecast factory, which is what he called it in a paper in 1922. This factory would be made up of people sitting in a stadium, and each person would be making calculations for a particular part of the globe. And they would share information by doing calculations by hand and passing it to the next, passing it to their neighbor, and so on, passing it around the entire stadium. There'd be somebody in the middle who would be directing and communicating information from one part of the stadium to the other. He was effectively describing what is today a modern computer, just a very slow and inaccurate one. He did the calculation himself. It took him, he was trying to make a 6-hour forecast, and he did the calculations with a slide rule, and it actually took him 6 weeks to make a 6-hour forecast, and it was completely wrong. So he had the concept there, but there were a number of different scientific advances that needed to happen in order to get us where we are today. So fast forward to nearly 100 years, and now we have skillful weather forecasts out to 3, 5, 7, even 10 days. Beyond that little ability to predict the detailed weather in any given location. And these are made with global atmospheric observations and models that are run on the most powerful supercomputers that we have today, which obviously nothing like what was envisioned in the forecast factory, but just lightning fast. So the key to making these predictions is very detailed knowledge of the atmospheric state. And then we can predict how it will evolve based on basic laws of physics. And so in this case, we know an incredible amount about the atmosphere, the temperature, winds, humidity, but we actually don't really need to know almost anything about the ocean in order to make these predictions. So you just heard about Mediterranean sea surface temperatures. Those will become important on longer timescales, but for these weather predictions, they really don't matter. It's really just the initial state of the atmosphere and then the laws of physics at work. So we use these same models in order to make these same types of models, global atmospheric models, to make predictions about the future well beyond the next 7 to 10 days. And in order to do that, these models, atmospheric models, are built on the same laws of physics, but in addition to having the initial atmospheric state, we can also prescribed changes about the greenhouse gases in the future. And so what you see here is a climate model simulations from the IPCC, the Intergovernmental Panel on Climate Change 6 Assessment Report, which just came out last fall, showing that showing future projections of the climate, the global mean temperature, and so what is shown here in black. I really want to turn around, but I'm told not to speak away from the microphone, so I'll just face here. So what's shown here in black is historical simulations up until about 2015, and then future scenarios are shown here, with depending on decisions that are made about energy sources and how much fossil fuels are in the mix for producing energy going forward. Obviously, this blue scenarios are ones in which we can limit the warming to within the Paris Climate Accord's targets of 1.5 degrees warming, whereas here in the red scenario, we ramp up greenhouse gases with basically no regulation. So the outcomes in this case, don't depend on the initial state of the atmosphere. They depend instead on economic decisions and human decisions about energy. Actually, something much more difficult to predict than the physical world, human activity. So now, we can already see that this global warming is already underway. So I'm going to pause and let this this is a picture of the global surface temperature over the entire globe in 5-year chunks, going from the beginning of observational period about in the early part of the century until today. So let me see if I can, sorry, I'm going to play this a few times because this is a really central point a couple central points I want to make here about the importance of the ocean going forward. So you can already see the warming, the global warming. If you kind of squint, you just see the whole Earth becomes red over time. But you can also see that there's a lot of variability embedded within this steady warming. In any given region, the surface temperature can be slowed or accelerated for extended periods of time. Climate has lots of variability then in between these weather timescales that I started with and long-term climate change. And that's actually what we're dealing with in terms of the next 5-10 years and preparing for those as a society. These kinds of regional surface temperature changes in the ocean can have impacts on the atmosphere, which can lead to variability in droughts, in rainfall, and in surface temperature that can produce multi-year climate fluctuations that are very impactful for many different sectors. So what is it that causes this variability within the global warming, embedded within the global warming? So this is not greenhouse gases. Obviously, greenhouse gases are going up globally, so it's not producing these regional changes. It's not the weather in the atmosphere, because those pass through in time scales of weeks, and they move through very quickly. And this is where we turn to the ocean. So why? The ocean has a large heat capacity, so we know, for example, in springtime, the ocean heats up much more slowly than the land, even though the sun is shining over both. That's an illustration of how the ocean has this large heat capacity, and Bev talked about that earlier, about how that can regulate climate and slow down the warming that is caused by greenhouse gases. The ocean also moves heat around, and it can pile up heat in a particular region, and because of the large heat capacity of the ocean, that can then in turn impact the atmosphere and the weather patterns and the climate and climate variability that then impacts people over land. So what I'm going to do in the rest of the talk is take a tour of the ocean and show you where these parts of, in what parts of the ocean that this regional climate variability can pile up water and then impact the atmosphere and the climate and weather we experience. So we'll start with the tropical Pacific. So who's here has heard of El Nino? Okay, good. So lots of people in the audience are raising their hand for those online. So this is the best example of where the ocean can influence the atmosphere is in El Nino. This is a picture of the last big El Nino event, which happened in 2015, where this is a surface temperature anomaly, so differences from normal. And you can see in the tropical Pacific that there are very large temperature anomalies up to 5 degrees Celsius, and they can last for several months and even an entire season, and sometimes even multiple years. These are caused by changes in the ocean circulation, with El Nino having reduced upwelling on the equator, and that leads to warming. And then we have an example of its opposite, which is La Nina. Here it happened the next year after a La Nina event, or after the El Nino event, and this is when there's enhanced upwelling on the equator. Now, we heard from UNESCO, these global organizations are really critical in helping to establish the kinds of observing networks that we need in order to understand what's going on and make predictions about the future. And this is a really great example of international coordination, putting buoys that are still maintained out in the tropical Pacific and have been there since the 1980s that give us information about what's going on there and what's going to happen in the future. This is a picture of the current prediction about El Nino going forward. Currently, we're in a third year of a La Nina event, and it's predicted to persist throughout the year. So here we are in winter time. This is a prediction from winter going forward, and you see that almost all these climate models predict that we'll stay in a La Nina-like state. And we can make these predictions thanks to both the models that we have developed, but also the important observational network that's out there. Because these ocean temperature anomalies last for up to a year, and in some cases multiple years, a large amount of heat can go into the atmosphere and change atmospheric circulation. So this is a picture of just an example from the North America of how the tropical Pacific can drive the atmosphere. So during El Nino event, you actually shift the jet stream south over North America. So it hits further south and it brings wetter, cooler conditions to winter time in the US. And if we look at La Nina conditions, it actually shifts the atmospheric circulation, the jet stream north, and the jet stream hits further north in Canada, and you get dry, arid, and warm conditions down here and wetter in the northeast. Now, this is a current picture of the drought situation in the United States. I'm going to pivot to talk about the Middle East in a little bit, but just want to show you this example of what's going on now. We're in a multi-year drought in some places. There's been a multi-decade drought in some parts of the United States, Southwest. This is not expected to be relieved this year because La Nina conditions tend to make it dry in this part of the country. So we're expecting another very dry summer and another dry winter next year. This is obviously, and you know, some of this is can be directly tied to changes in the ocean. So the ocean is extremely impactful for these kinds of multi-year, multi-decade droughts. So let me shift gears and start talking about the Atlantic Ocean now. So this is a picture that is attributed to Benjamin Franklin from 1976. I'm not sure if that's exactly true. It's become kind of mythology at this point. But even in the 18th century, there was a recognition of what is now come to be known as the Gulf Stream, which is this strong current that passes through the Florida Straits and then follows into the North Atlantic and then actually spills out into the far North Atlantic. This would be wrong because now we understand that there's a North Atlantic drift, where water actually is transported far into the North Atlantic, and bringing warm water off the coast of Northern Europe. So the Atlantic has an incredibly long history of observations, and people, for over 150 years, there have been regular transatlantic temperature, salinity, winds, sea level pressure, all reported centrally and logged centrally with a quality-controlled global data set. So we really have a good understanding of the long-term changes of the Atlantic Ocean. And what that data tells us is that the Atlantic has warmed in general. So this is a picture, it's a time history of the annual average temperature of the entire North Atlantic, going back to 1850. And what you see is that obviously the Atlantic is much warmer now than it ever has been, and you can see that here in these bars. But what you can also see is that warming was not steady in the Atlantic, that there were these fluctuations about a warming trend, which lasted for multiple decades. So let's see. What I'm going to talk about for the rest of this talk is how these multi-decade swings in the Atlantic Ocean temperature impact the atmosphere. So we'll start with Atlantic hurricanes. So this may not be as big of an issue here as it is for us living in Florida, but this is an example from 2017, which is the most active year on record in the Atlantic, where there were, this is just one day where there were 3 major hurricanes. This is Katia, Irma, and Jose, followed by Hurricane Harvey, which dumped a record amount of rainfall over Houston, and Hurricane Maria, which basically destroyed Puerto Rico. So this was an extremely impactful year with record setting. But one of the things that if we look back in time, we can see that 2017 was during a period of overall high activity, which actually lasted for multiple decades. So this is a picture of the time history going back to 1950 of the Atlantic hurricane activity from NOAA. So there was a high activity period in the 1950s, a low activity era in the 70s, mid-90s, and then since the mid-90s, we've basically been in a high activity era where every year we set new records for numbers of hurricanes and impacts of hurricanes and intensity of hurricanes. And as you can probably see, there's these multi-decadal swings actually correlate with the Atlantic surface ocean temperatures in a way that makes a lot of sense. When the Atlantic is warm, there's more hurricane activity. When the Atlantic is relatively cool, there's less. So some knowledge of this ocean state can tell us, can hopefully tell us of where we're headed in terms of long-term changes going forward in hurricanes. These changes in Atlantic Ocean temperature also impact the Middle Eastern climate. This is a picture from a recent paper showing summer surface air temperature over the entire globe that is correlated with North Atlantic multi-decadal swings in ocean temperature. And you can see that one of the largest correlations is right here over the Middle East, and actually with Israel sitting right in the middle of that summer temperatures are several degrees warmer when the North Atlantic Ocean is warmer. So this is, there's obviously been a rapid warming trend in this region, but there was, the mid-century in this region was actually somewhat cooler than the global average and relatively mild, and this is in part related to the cooler ocean surface temperatures. I'll also mention, you can see, I'm just going to give you a little preview that looking at North Africa, you can see that this is one part that it's actually cooler in North Africa, and this is because rainfall goes up in North Africa when the North Atlantic is warm, and you're going to hear more about that from Kenny Broad from his talk later after the break, where this can actually impact the amount of dust that is emitted from North Africa and as part of these multi-decadal swings around in the Atlantic and its impact on the atmosphere. Okay, so unlike El Nino, where we've had now almost 30 years of continuous observations, we do not have we don't have as good an agreement about the mechanism that produces these multi-decadal changes in the Atlantic Ocean. So this is supposed to be a video playing. Let's see if it plays. All right, let's see. So this is going to be a video. It worked before, I swear. Oh, there we go. Okay, so this is a video that is an illustration of the global ocean circulation that brings warm water into the North Atlantic. So the Gulf Stream, as I mentioned, brings warm water up the coast, spills into the far high latitudes of the North Atlantic, loses heat to the atmosphere, sinks and returns as cold water flowing out. So overall, this circulation is making the North Atlantic unusually warm. And I think everyone is familiar with the idea that Northern Europe is much warmer than other longitudes like New York or even the west coast of the US. Northern Europe is much warmer, and part of it is because of the warm ocean water that sits in the North Atlantic that is there because of this ocean circulation. So one idea is that changes in this ocean circulation can drive these multi-decade changes in the Atlantic Ocean temperature. When the circulation speeds up, it brings more heat in, which then has the impacts on hurricanes, on Middle Eastern climate, and potentially on Saharan dust as well. So one of the ways that we know now, there's currently an observational array out there in the North Atlantic. It's a European, North American collaborative. So there are moorings all the way across the Atlantic Ocean, continuously measuring this ocean circulation changes. And this mooring array was established in 2004. So we really don't have this multi-decade view of things. But if we look at, if we use the available observations that, that people can pull together, let's see, what's happening? Okay, did I lose? I want to show that. Keep going. Right here. Oops. There. Oh, back one.
One back.
Yeah. There we go. Okay. So if we look at the time history of this ocean circulation, what's shown in red are the observations from that mooring array that's been there since 2004, and black is we can extend that going back a little bit further with ocean models. And one of the things that you see is there seems to be a downward trend in the strength of this overturning circulation. So while that circulation brings warm water into the North Atlantic, if it slows down, it brings less, which actually makes that North Atlantic cooler. So the implication, if this were to continue, is that we would have a less active hurricane seasons, and that summers might be a bit more mild here, and counter the overall influence of greenhouse gas warming. But there's also another theory of what drives these cycles, and this is actually very close to the work that I've been involved in the last about 5 years. So this is a picture of the time history of anthropogenic aerosols. So anthropogenic aerosols is basically soot, smoke, particles that are put into the atmosphere as a result of fossil fuel burning and other anthropogenic activities. And if you look at the time history from from North America and Europe, you see that in the post-World War II period, there was a rapid increase in the amount of atmospheric aerosols this is actually over the entire globe, that is due to activity in Northern America and Europe. But around 1980, Clean Air Act in the United States and in Europe as well were developed in order to improve air quality. And as a result, there was a big decrease in anthropogenic aerosols that happened post-1980. And this is the aerosol that will be out over the Atlantic. Aerosols scatter sunlight, and they actually have a cooling effect. So there was a cooling effect due to these atmospheric aerosols in this period from about 1950 to about like the mid-1990s. And if you recall, that was exactly the cool period that we saw in the North Atlantic. So that the hypothesis here is that human activity caused anthropogenic aerosols that cooled and lowered the Atlantic surface temperature, suppressed hurricanes, and made the Middle Eastern climate more mild. So we can look back at this history of the Atlantic climate and look at this period, which would have otherwise been warming due to greenhouse gases, and show that maybe there's an influence not only of ocean circulation, but also from human activity in driving these temperatures down for an extended period of time. Now, what can we expect for the future? So the Atlantic, this overturning circulation in the Atlantic is expected to slow down as greenhouse gases increase in the atmosphere. The latest from the IPCC says it will very likely slow down over this period, and there are hypotheses that it will abruptly collapse and stop. There's currently medium confidence about this. So while the history of the Atlantic may be in part caused by changes in human activities and atmospheric aerosols, going forward we expect that the Atlantic, this ocean circulation is going to have an influence on the Atlantic Ocean temperatures, which will then have impacts on the atmosphere. So let me just wrap up, because I know we're short on time. Does the ocean matter for predicting future climate change? And just a few points. With El Nino and La Nina, we have a very good understanding due to international collaboration on models and observations in order to make predictions. We make these regularly. The impacts are well understood and well observed. But there's also clearly seasonal and decadal variability in the ocean outside the tropical Pacific that can impact climate. And there's still real scientific debate about what is the role of the ocean versus what is the role of these anthropogenic aerosols and changes in the atmosphere in predicting these multi-decadal changes. And I'll just pause for this, the students that are in the room, that this is actually like a really exciting topic within the science community that we don't really have great answers for, and so there's opportunities, I think, for really exciting new research going on. And we'll be around tomorrow to also talk with any students that are interested in this. We have great opportunities at the University of Miami for working on this. And we're just starting to get a more complete view of the global ocean's rich variability. And this is I'll just leave this up, is if it plays. So this is a global view of the ocean circulation and all its complexity. We don't need sound on this, it's okay. Just want to mention that there's an interesting statistic that if you look at the overall volume of the ocean, less than half of the volume of the ocean has ever been observed even once. With an instrument, and so I think what we're starting to see is that we have a global capability to make observations about the ocean, and every time we do, we see there's all this complexity and richness which has consequences for the atmosphere and for the marine ecosystems and for the people that depend on these things. And so I think it's a really exciting time to be in ocean research. There's so many interesting questions and opportunities of real societal importance that so I'm really excited to answer any questions and hear from you all in the next couple days about all the exciting research going on in the ocean. So I'll stop there. Thank you. Tadaraba.
Thank you so much. We do have a few minutes for questions before we start the flash talks. Would anyone like to ask a question? I have many questions if no one has a question. Well, I'll start. Oh, wait, I see one. Yes?
So the question was are the aerosols linked to the ozone hole? And it's a really good question. There's a really interesting, I think, global ocean and atmospheric consequences to the ozone hole. But these particular anthropogenic aerosols are mainly produced by coal burning, whereas the ozone hole is mainly produced by chlorofluorocarbons, which were like associated with freon use and refrigeration. And those are mostly banned now. And so, but they only since the Montreal Protocol in the early 80s. So the ozone hole is related to different atmospheric gases and then the chemistry that follows from them than these anthropogenic aerosols. But they are both examples of where we're putting stuff into the atmosphere, not just greenhouse gases, but lots of things in the atmosphere, and they can have consequences that are very far and very far from where the sources are, and very consequential as well. So great question, thanks.
I wanted to ask just a quick question about, you were talking about the cooling effect from the aerosols. So of course the question immediately is, maybe we put more aerosols into the atmosphere. Yeah. So I guess if you could say a little bit about that and the recent volcano of Tonga and what expectations, whether or not that might help to counter. Yeah.
Oh, great couple of questions. So one is about, anthropogenic aerosols. So these are like what are being put in by humans versus natural aerosols, which are coming from from volcanoes, for example. So first, just about anthropogenic aerosols. So geoengineering, another climate solution, a temporary one, a risky one. I think the latest on this is there is a lot of interesting research going on with geoengineering. Should we purposefully put aerosols in the atmosphere that will cause cooling of the ocean temperatures, which then will hopefully have the same impacts of lowering hurricane activity or reducing the temperatures here in the Middle East in the summertime? I think that the big questions are that are still remain to be answered, and I think will prevent us from doing anything purposeful along those lines are: one, is it scalable? Can we produce aerosols at that scale that will lower the temperatures in the way that we hope? And two, what are the intended consequences of that, which I think is our big questions. Will it end up moving rainfall patterns around in a way that is not equitable for people that depend on particular rainfall patterns? So that's I think a great topic of conversation going forward is geoengineering, but it's really, I would still say, in the research realm, not ready to be applied yet. And the second one was about volcanoes, and one of the interesting things about this time period in the 1960s is there was a lot of also major volcanic activity at that time, some of which may have contributed to this cool period that followed. So, and typically, as it relates to Tonga, you need, a volcanic event will put a lot of aerosol into the atmosphere if it's strong enough if the event itself is strong enough, that aerosol will reach the stratosphere, in which case it will take a long time to settle out, and it will be able to spread globally before it settles out. Mount Pinatubo was the last big event, which you can kind of see its influence right here in global temperature, that was big enough to have that kind of impact. So it either has to be a giant event, which Tonga was, but then it also it will still only take a couple years for the atmospheric aerosols to settle out from that. And what was unique about this period of time was that there were several large volcanic events. So it was kind of pumping aerosols into the atmosphere, which stayed for an extended period of time. And so I think one event on its own is probably going to have a minimal influence. I don't think Tonga was as big as Pinatubo, which you could see in global temperatures. So, great questions.
Great. Thank you so much. So, thank you.
Thank you. So we will now move on to the flash talk session. Okay, so this next part of the session will be dedicated to hearing about active research related to climate change in the oceans from the students themselves. These students will be presenting posters, which are located just outside the auditorium in the hall. But first, they'll provide a brief overview of their work in short flash talk presentations. Thank you. Also, we will be having an award ceremony at the end of the conference, and 2 of the awards will go to the best poster and the best flash talk as chosen by the audience. So we have a QR code located in various points outside. One is at the registration table. I believe another is hanging next to the posters. And you can scan the QR code and vote for your favorite talks. So, so we will begin with Karen Pitlick.
Okay. Hi, I'm Karine Pitlick. I'm a research assistant and primary developer at Dr. Mustafa Asfour's lab at Rupin Academic Center. And I want to briefly show you a study we made about the effects of climate change and Nile damming on the intensity of lightning flashes in the Mediterranean Sea. So a brief overview. In the 1970s, the Aswan High Dam was built, and it controls the sweet water flow to the Mediterranean Ocean. And combined with the climate change, we see chemical alteration in the chemical properties of the Mediterranean sea water. And our study aimed to see how these chemical changes affect the intensity of lightning flashes in that sea. So we employed 2 approaches. The first one was an experimental one. We conducted laboratory artificial lightning flashes from water sampled from the Mediterranean Sea. And the second one, we built models based on information provided us from Copernicus and WWLN. So after we built the models, we saw that there are very positive and good correlation between salinity, total alkalinity, and pH on the intensity of lightning flashes. And we estimate that since the 1960s, there was a more than 16% increase in the intensity of lightning flashes. And we estimate that by the year of 2050, there will be over 25% addition in the intensity of lightning flashes. And although the climate feedback is very complex and there are a lot of factors that attribute to all the climate feedback. We think that overall the LFI is a way to monitor the climate change process, and also LFF, which is lightning flashes frequency. So I'll be there in the hallway if you want to ask more questions, and I'll see you there. Thank you.
Okay, so the next is Nadav Cohen.
Thank you. Okay, what if I told you to navigate in a place you're not familiar with? What if I told you you can't use Waze, Google Maps, and it's so dark outside you can't see your surroundings? Well, this is exactly what the autonomous underwater vehicles, or AUVs, has to do. The AUVs were developed to perform tasks in the great depths of the ocean, where human cannot reach, and GPS certainly doesn't work. And in order to do it effectively, it has to operate or navigate autonomously. To that end, the AUV is equipped with the DVL, or Doppler velocity log. This sensor transmits 4 acoustic beams to the seafloor, and once they're reflected back to the sensor, raw data is stored. By passing this data through a common least square filter, we can estimate the AUV velocity, or speed. We suggest a different approach. By utilizing data from the inertial measurement unit, which is also a common sensor used in the AUV, and the data from the DVL, we can train a deep learning framework. By doing so, we provide some kind of artificial intelligence to the AUV. We performed a 4 hours experiment with the AUV in the Mediterranean Sea, and by using the data from the sensor, we were able to train and test a deep learning network, we call it BeamsNet, that resulted in improvement of more than 60% in the AUV velocity measurement. To sum up, by teaching the AUV its common path, trajectories, and maneuvers, we're able to significantly improve the AUV velocity measurement, which translates to better navigation. And the best thing, well, it's a free meal, because from every experiment we get the sensor data. And we use this data to further improve the AUV navigation. And I think that every Israeli here would tell you there is nothing better than a free meal. Thank you.
So the next talk is by Ernest Zansky.
Hello, everyone. First, gaseous sediments of shallow lakes are a source of a major concern because they strongly destabilize sediments, and also they strongly affect the global warming, because methane is a potent gas, global heat-trapping gas, with a global warming potential of about 25 times larger than that of CO2. So just briefly, all right. So we study Lake Kinneret, which has a lot of organic matter content, which is shown in the upper left figure. A lot of organic matter content in the sediment leads to high methanogenesis, which leads to high gas bubbles concentration in the sediment. And we study sediments and gas bubbles concentration for more than 7 years already. And we carried out several acoustical experiments to estimate free gas content in the sediment. We made several estimations, and after that we asked the question, what causes fluctuations of the gas concentration in the sediment? And several years ago we published a paper showing that there is direct connection between lake surface level, which is shown here in the middle top picture. You can see that lake level is fluctuating from one year to another. And there was direct connection between free gas content and lake surface level, which is shown in the middle bottom picture. When lake level is low, there is a lot of gas, and when lake level was high, there was almost no gas. So it was nice and easy until we made 3 more acoustic experiments last year and in 2019, and we saw really strong deviations of gas concentration. And if you want to know what can be the possible reasons for such a big increase of gas content, please come and see my poster.
Thank you. We now have to move on to 2 video flash talks. They unfortunately couldn't join us in person today. The first should be by Rem Neary.
Dear friends, it gives me great pleasure to address you today at this conference dedicated to the relationship between the ocean and climate change.
Oh, we don't see the video.
Clearly, without life in the ocean, there will be no sustainable life on Earth. From a climate viewpoint, the ocean regulates our climate by absorbing huge amounts of heat, generating 50% of the oxygen we need and absorbing 25% of the carbon emissions. But despite its crucial role in sustaining humanity, the ocean is currently facing unprecedented threats. We humans have directly disrupted the ocean ecosystem, and climate change has further impaired it. This conference is very timely. Later this month, senior representatives from all over the world, including Israel, will gather in Lisbon for the UN Ocean Conference to evaluate our progress towards Sustainable Development Goal 14, life below water. But more important, delegates will discuss how humanity could and must further protect our oceans. Action is needed by all countries at the national level, regional level, and multilateral level. In the Mediterranean basin, the climate is changing faster than global trends. Israel has stepped up actions to fight climate change and protect our seas. Recently, the government approved a climate law that creates mechanisms to reduce emissions and prepare for climate change and its risks. Israel is also acting to expand protection on marine life in the Mediterranean and the Red Seas. Israel has declared a few marine protected areas in recent years, and last week I declared the Palmachim Disturbance Sea Area as the first MPA in our exclusive economic zone that doubles in size our marine protected areas in Israel, with close and crucial involvement of research institutions such as Haifa University and Israel Oceanic and Limnologic Institute. Israel is also combating marine litter pollution with the Clean Beach program and several actions to tackle plastic pollution, especially harmful to the marine environment and its biodiversity. We are also working on a regional scale with our Mediterranean neighbors and with our Abraham Accords partners to prepare for the impacts of climate change and to protect our common marine environment. Just 2 weeks ago, at a regional meeting in Limassol, I discussed with fellow ministers how to jointly address the climate crisis. We also work with Cyprus on a joint project to promote climate-adapted, integrated coastal zone management. And later this year, we will host in Israel a trilateral Israel-Greece-Cyprus marine oil pollution contingency workshop. Finally, at the global level, Israel is proud to take an active part in a process to develop a new legally binding instrument to tackle plastic pollution, including marine litter. Of course, as policymakers, we must rely on solid scientific evidence. It is therefore essential to strengthen the science-policy interface at all levels. I therefore see much importance in this conference, and I wish you much success. Thank you.
Oops.
Okay, thank you, everyone. We are actually going to do a small switch in the schedule because of the timing. We have to stay on the schedule for the virtual, and because we had some of the technical difficulties. The flash talks, the 2 flash talks that were recorded, we're going to hold on until the next flash talk session. I apologize for that. I know some people came to see that at this time, but in order to stay on the overall schedule, we're going to have to shift those recordings. And so we will play them during the break if for those who want to see them right now, but we will replay them later. And now we're going to have a coffee break. So thank you, everyone. This is the completion of the first session.
איתמר, הרשת הווי-פיי שלהם חוסמת את האנידסק.
מה הווי-פיי של האולם שעובד?
כרמל.
זה לא עובד, אין לו כוח. אין לו כוח.
כן, זה מה שיש.
אין לך, אתה לא יכול. הרשת מחובר בקווי לזה, ל-NDI.
אז תחבר את הווי-פיי
אז אני אחבר את הווי-פיי, אתן לך ווי-פיי. אבל זה מחובר לעין כרמל הזה.
עזוב את העין כרמל, תחבר ליוקי.
לא יודע אם הוא יקלוט אותו מפה.
קולט. כשלחצתי שם, עד שהגעתי לפה כבר נעלם מהפרומות.
לך לשם, נו. מה שאתם רוצים, שמישהו יגיד לנו מה לעשות רק. תודה. אוקיי, מצוין, תודה. רק שנייה. כן.
האם אתה מעדיף שזה ככה בלי סטודנט שאחראי רק על לשלוח מצגות ולעשות קריאה? אפשר לרגע.
לא, לא עשינו איתו חזרות, עזבו אותי מזה. כן, רואים אותך. אוריאן, תן. תכווני לך את המיקרופון, לא יבוא מישהו לכוון לך. כן. פשוט מושכים אותו ככה.
אוקיי.
בסדר? בדיוק. You next? אתה בא בתור? להסביר להם בבקשה. מתכוונים להסביר להם. יופי. תשמרי את הדברים שלך אצלך, יש פה רכבת שלמה של אנשים. מה? תנסה להתחבר.
דבר.
לאיזה רשת אתה מחובר? מה? שנייה, אני לא שומע. מה? עוד שנייה, אנחנו מטפלים פה במשהו אחר. כן, אני איתך. 071. כנראה שיש פה חסימה ברשת הזאת לא, אני לא מצליח להתחבר ליוקי, זה רחוק מדי. אז אי אפשר, די, אז אין לי דיסק, די, מספיק. הסבזתי על זה יותר מדי זמן. עזוב אותי, אין, נגמר. תראה שאתה מקבל את ה-NDI בבקשה. תראה עכשיו שאתה מקבל.
media for last mobile fishery data in conflict zone. Hello, I'm Reem Neri, and I'm going to talk about mining social media for last mobile fishery data in conflict zone using the Gaza Strip as a case study. Conflict zones are categorized with terrestrial disputes, military conflicts, and encompass large swaths of coastal regions, which suffer from unsafe or impossible access, no regulatory agencies, no international repercussions, and rapidly changing landscape. This caused a major gap of environmental data available for research. Our study site, the Gaza Strip, is in intense conflict in the last decades, during which access to marine areas is often restricted, and the only catch estimation is by self-report by fishermen. Located at the eastern Mediterranean, the Gaza Strip was known for a bountiful fishery since ancient times. In the last decades, marine blockade and bathymetry influenced catch. A last mobile catch was never detailed and described to specific groups. Lack of ice and refrigeration pushes vendors to use real-time broadcasting, in example Facebook Live, to advertise their merchandise. Using these videos, we can manually log important fishery data such as date, time, specimen count, vendor name, price, location, and sometimes also the sex of the specimen, total length, disc width, and weight. To this point, we have collected 584 data points in which rays and sharks are being photographed as daily catch in the Gaza markets. The largest fished group in this period were 2 species of guitar sharks, 2 species of rekin sharks, followed by stingrays and hound sharks. As for temporal distribution, we see more conformity after the extending of the allowed fishing zone between 15 into 50 nautical miles after June 2021, which afterwards we see a similar distribution of catch every month on the right side. This is believed to have to be in a connection to increase fishing depths to where certain species are known to use as habitats. Thank you very much.
Hi, my name is Semyon Polinov. I am a PhD student in the Department of Marine Geoscience in the University of Haifa. In this presentation, I want to present you the results of study of spatial interpol analysis of oil spills in the Mediterranean Sea. About 50% of all petroleum reaching the marine environment is human produced, while natural processes such as geological sieves and earthquakes account for the rest. The ecological impact of natural oil sieves is limited given their steady input rates. In contrast, the shipping industry is a major contributor to catastrophic and chronic marine oil pollution, given the large volumes of oil that can be released in this single event and chronic pollutions. The most common means for remote oil spill sensing is to use optical and radar observations of the sea surface to detect and map oil spills. In these 2 images, you can see the use of 2 types of satellite images that allow us detecting and tracking oil spills on an example of coastal spillage accident that started last year in August 2021 and still continues from Banyas refinery factory. Using relatively simple image processing techniques, marine pollution events can be identified and validated with high accuracy. In the right image, you see the distribution of oil spills affected by satellites. High concentration of oil spills were located farther away from the coast, in the deep sea areas. In the left image, you can see the distribution of tanker oil spills, with spillage higher than 7 tons. Based on reports, the Mediterranean coastal zones were exposed to higher concentration of tanker oil spills than deep sea areas, apart from episodical accidents in the deep sea. Conclusion of the research are: shipping the main source of marine oil pollution. 90% of tanker oil spills occur close to the coastline, and the main concentration of delivery discharges from ships is located 22 to 100 kilometers from the coast. In the last 20 years, the number of oil spills from tankers has significantly decreased and approached zero-speed standard, while delivery discharges stayed stable or even increased. Levantine region, hotspots of delivery oil pollution from vessels. The most sensitive effective technology for monitoring marine oil pollution. Thanks for your listening.
This is the Home Biogas 100, a simple-to-use, cost-efficient system to tackle the ever-growing price of waste disposal in the commercial food service industry. The Home Biogas 100 instantly converts waste on-site and redirects it as hot water. The user-friendly interface can be controlled remotely and saves valuable time with an indoor feeder hatch. It's compact and installed outside any business, taking up only 2 parking spots. Each unit minimizes your carbon footprint and preventing the release of 2,000 tons of carbon dioxide into the atmosphere every year. It's affordable, safe, cost-effective, and has a great return on investment for restaurants, diners, hotels, hospitals, schools, companies, and more. How does it work? Food waste is disposed into an indoor feeder unit, transferred to the digester, where it is anaerobically decomposed into gas. The gas energy is converted into heated water, which is redirected back to the business and integrated with the existing water system, creating a self-sustained ecosystem for the business, cutting on waste disposal costs, saving on energy bills, and reducing pollutants released to the environment. Home Biogas, a sustainable system for self-made energy.
Thank you so much for having me. I want to start off by telling you a story about glaciers.
Debbie?
בעיקרון יש פה את הפוינטר, שתדעי שזה קיים. Itamar. Itamar.
Right now, they're trying to show me how to launch it as well. It's launching here, but not there.
Yeah, I think they
I don't know what they control. That's nothing. So it looks like this is how they launch it. That's probably why it works. כן, הוא רצה לבדוק עכשיו. Kenny? Yes.
Okay.
I don't know which one is you, but it's just...
PowerPoint.
This one, right?
Oh, yeah, that is. Yep. So, and then for me, do I start it or they start it?
I think we'll have you start it,
Right
just
there.
because
Okay.
I feel like this is
Yeah, and then can
an
I use the
ongoing
clicker?
issue. Yeah, the clicker, yeah. So, good to use the clicker, because everyone's
Okay,
saying they
oops,
can't
I
see
think-
the mouse.
Okay, that's good.
This is the beginning, right? Yeah.
Black.
Okay.
Yeah.
Just want to make sure that it runs well. Yeah. Perfect. Amazing. Okay. Thank you, Kenny.
But it's back. We're back to the first one, right?
Yeah. It goes back to the first. I'm gonna close this and
No,
then.
actually, go to this. Just click on it. Okay. Now we're
Okay.
okay. Thanks.
We'll be here.
Thank you. You guys seem stressed about like
Had
all our basically every conference I ever go to, there's always tech problems. It's normal.
Thursday, the biggest on Thursday.
You practice it all.
It
It went perfect. That's how it goes. You never practice. That's my thing.
Well, we didn't really practice because no one actually came to practice. What? Who's the next one?
What last one? The video? The next one.
What's the next part?
It's going to be Roy Rector, and it's you, Kenny.
Oh, okay.
Okay, so Kenny's
But
is already.
I'll do it because it's. You want to just keep it up on the screen?
Kenny's is open here. Okay.
The first one is a black one. Yeah. Perfect. Okay.
Good.
Turn this off so no one hits it by accident. All right. Great. Thank you.
Okay.
Okay. Good morning, everyone. The mic is not, is it on? Good morning, everyone. Please come in and have a seat if you can. We are on schedule. Everyone, good morning, please. Head to the audience. Thank you. Please find your seats. Thank you. Good morning, everyone. Please come, find your seats. Thank you. Okay, good morning, everyone, the third time. So this is going to be the second section of the Climate Ocean Change Conference here at the University of Haifa, and also welcome everyone who is watching us online. My name is Ákos Kálmán, and in this session, we're going to be focusing on the evidence of the climate-ocean change relations, and we present some of the evidence for recent climate changes that are affecting marine environments. And I would like to welcome Cili Czerny, who is sitting here in the audience, the founder of our marine school, and thank you for all your efforts and help for the family. Thank you. So first, I would like to invite Professor Gur Aroy, Director of University of Haifa, to give his introductory remarks.
Good morning. Welcome to the University of Haifa. I am excited and proud to greet the conference participants and the organizers. In the past year, we have made a strategic decision to focus on sustainability. The 2030 Agenda for Sustainable Development, adopted by all United Nations member states in 2015, provides a shared blueprint for peace and prosperity for people and the planet, and now into the future. At its heart are the 17 Sustainable Development Goals, SDGs, which are an urgent call for action by all countries in global partnerships. To implement our vision, we have adopted the SDGs. We have adopted sustainability as guidelines of our research, but also as a campus lifestyle. It is only natural that the marine sciences should be an integral part of such academic revolution. I am glad and proud to announce here that the Czerny School of Marine Sciences was part of the Faculty of Natural Sciences, and today is an independent school which will become the 7th faculty of the university in the very near future. As rector of the University of Haifa, I intend to make every effort to make the university a leader in Israel and worldwide in marine studies. We will not spare any resources to do so, both in hiring new faculty members and in building new labs and opening new programs and departments. A new department will be opened soon at Czerny School of Marine Sciences, Blue Tech, and Sustainable Marine Culture. Also, In the coming year, some groundbreaking developments are expected. I will avoid talking about it now, but when the time comes, everyone will know about it. I would like also to take this opportunity to thank Tzili Charney on behalf of the university and myself for her commitment to this school, which is the diamond of the university crown. Thank you, and thank you again, Tzili. And I would like to end my short reading with a poem by Azriel Kaufman, The Sea of Achziv Tide, translated by Duffy Weichard. It started early. The sea had grown great and glorified, and then came rain, and placed everything under a soft canopy. Now the beach stretches in purple seaweed, and in between the seagulls hold their breath. I wish you all, and for us, that the seagulls always hover above you and the University of Haifa. Thank you and good luck.
All right. Our next speaker is Kenny Broad, who is a professor in the Department of Environmental Science and Policy at the University of Miami. He is an environmental anthropologist, or if I can say human ecologist, who is focusing on the relationship between humans and their environment. He is also a cave diver, and he understands the language of blue holes. Kenny.
Not so tall. Can you hear me okay? My hair, okay? Good to go. Well, let me also just quickly add my thank you to all the organizers, Shalom. I actually used to speak a little bit of Hebrew. I went to Hebrew school when I was very young. The only thing I remember I was telling Ilana was the teacher, after hitting me, saying, Sheket bevakasha. So I hope it goes better today as well. I'm going to talk about, I would probably argue, one of the least understood parts of our planet, probably because it's one of the least explored. And I know we have a lot of underwater exploration going on here, so I sort of focused my talk on underwater caves, or what in the part of the world in the Bahamas that I'll talk mostly about they're called blue holes. In Mexico, cenotes. In North America, we call them sinkholes. And I know you're very familiar with all sorts of water resources here, and you have some large aquifers, both coastal and in the mountains. So I think a lot of the information will resonate. And I know we're at a conference that's marine science oriented, but what I hope you'll see is you really can't distinguish either biologically, certainly climatologically, but also in terms of natural resource management. We often manage our coasts and our inland resources and our underground resources separately, but they're really intricately intertwined. So let me just start. I would say, how many divers do we have here in the audience? Oh, thought it smelled. Any cave divers? Oh, we've got a few. Well, for those of you who don't cave dive, that's what an underwater cave looks like. Oop. How do I thought my first slide was up here. I'm better underwater. Can we switch to my presentation? There we go. That's what it looks like. I took this picture myself. I'm pretty impressive. That's what an underwater cave looks like from the photographer's viewpoint, from about 100 meters down, looking at two of us descending down into one of these blue holes. I'll talk about two types of connected blue holes. There's inland, So that's in the middle of a forest in an island called Abaco in the Bahamas. And then ocean holes. This is Dean's Blue Hole in Long Island, Bahamas. This is about 220 meters deep, the second deepest known blue hole in the world. And as you can see, it's an ocean saltwater blue hole. I think probably many of you are geologists and in the audience are earth science, but for those of you who don't know how these holes form, if we go back to the last glacial maximum about 20,000 years ago when sea level was well over 100 meters lower in most of the world, you had much larger land platforms, particularly in this part of the world where the Bahamas, very close to Florida, almost connected. But you have rain that falls through the atmosphere, picks up a little carbon dioxide, becomes slightly acidic, hits the ground. In many parts of the world is limestone. And this slightly acidic rainwater mixes with the sediment, becomes more acidic, and that's how we get these underground pools or reservoirs in these aquifers of fresh water. If you take away the water that's locked up in ice, really about 95% of the world's fresh water is beneath our feet, out of sight, out of mind, and it's so often ignored when it comes to environmental protection and resources, but it's our critical source, which I think in this country I don't have to emphasize. But when you have this thin, lighter freshwater lens, it's sitting on top of salt water when you're anywhere near the coast. And it's at that halicline, that interface, where you can have extensive cave networks formed, and that's how we get our groundwater moving to very distant lands. And that's some of the areas that I'll talk about exploring. But then as sea level rises, it'll then inundate these dry caves, and those are the areas where we have our groundwater reservoirs. And again, it's that thin layer of fresh water above the denser, heavier salt water. And as we get saltwater intrusion associated with sea level rise near the coast, it's a threat not just to our drinking water resources, which we're familiar with, but I hope to show you also there's many other biological, biogeochemical, and climate reservoirs that are threatened in terms of our knowledge and knowledge of the past and the future. Just for those of you, the Bahamas, most people think of it as one or two big tourist areas where you gamble away your kids' college money or drink tropical drinks, but it's a large about 1,000 kilometer long where you have very deep trenches and shallow carbonate banks, so you can do a lot of natural experimentation on migration of species, on a very important climate region in the North Atlantic that Amy talked about earlier. So it's a critical area for all sorts of different types of scientific endeavors. And because it's such a low-lying area, these underwater caves, these sinkholes, they're really time capsules. And just to briefly preview, this is a cross-section of a sinkhole called Sawmill Sink. You've got that thin layer of fresh water. You've got oxygen in those first, about 10 meters. The oxygen diffuses very slowly. I think, one molecule of oxygen, it takes about 8 years to make it down about 10 meters, so quite slow, faster than we do things in the US Congress, but still much more efficient in the sinkhole. But then it hits a certain layer of hydrogen sulfide where there's microbes that then will metabolize that oxygen, so you have anoxic, no oxygen salt water beneath it, which is very similar to what our early oceans were like, right? Sulfate and no oxygen in the photic zone. So it's, from a biogeochemistry, it's sort of an earthly analog, not only for what we think the earliest oceans, the ancient oceans were like, but also is a good place to look at extremophile forms of life that can live from the photic, the light zone, into the dark zone. And it can help us sort of narrow down where life might exist in other planets as well. So a lot of astrobiologists we work with in studying these areas. There's a chemical process with the microbial decomposition that goes on from all sorts of detritus falling to the bottom. It mixes with the sulfate, and one of the byproducts of these microbes is hydrogen sulfide layer that I'll talk a little bit about before. But because of this anoxic salt water, it's one really interesting for studying some of the earliest forms of life. 2, for preserving fossils, because this is an area that we know very little about the natural history in the, this is not technically part of the Caribbean, but the whole area that's scoured by hurricanes. And then directly related to climate, you have stalagmites and stalactites that grow in the caves that we can use, as well as the sediments, to use for paleoclimate reconstruction, so we can see what the natural variability in the climate was like, and then compare that to what's going on now and the anthropogenic influences. Voila. So we use very high-tech exploration techniques. You might recognize the probe. You can't necessarily tell from satellite what something's going to look like, so you literally, it's sort of a metaphor for life. You just have to stick your head in and in and in. My mother came to a presentation, and really her only comment after the whole thing was, you went to school for how many years to do that? So for all you students out there, keep working hard and you too can end up there. But once you get into these areas, you really can see this connection. So you go in the ocean, those are the roots of mangroves coming through about 60 or 20, 25 meters of peat into the salt water that we swim through. And when you go in far enough, you go 500 meters in, you can get into fresh water. So again, this artificial disconnect of coastal zone management and terrestrial management is, as I'll show you in a video. There's all sorts of, and again, I'm putting things in here that I hope will spark students or anybody interested in studying what's really understudied, particularly some of the exits to these caves out in the ocean are biodiversity hotspots because they have different different temperature, they're cooler water, and they tend to be have higher nutrients. And because of the connection to land, you also have the risk of pesticides and other sorts of pollutants. Just because I knew we had a lot of divers in the audience, I threw in some diving videos. Cave diving, just as a liability disclaimer, very different from open water diving. Of course, if you have a problem, you can't come right to the surface. You've got to deal with your problem underwater. So it's all about risk management and backup systems. So you have independent sources of breathing gas. You only use a little bit of your gas going in, a little bit for coming out, save a lot for emergencies. You always run a continuous guideline to the surface. A lot of what we take for granted in recreational diving now were innovations that came out of back, this is about 25 years old, this video, and where we were sewing our own harnesses so you could take tanks off and push them ahead. So there's several sort of golden rules: backup lights, backup masks, backup fin straps. I always like to dive with people much bigger than me, and I figure if they let them go first, if they can fit in the hole, as long as you get in front of them on the way out. But it's much more of about breath control, and I'll show you. I have another kind of older video to show you how dramatic that is. So this is about I don't know, 400 meters offshore in the reef. That's in about 20 meters deep, and the water actually on a certain tide is boiling and pushing out. This is water that's coming from inland, so it's actually of a lower salinity than the ocean. So again, it's lower salinity, lower temperature. So particularly in a warming atmosphere, these tend to be hot spots, which is interesting to think about from a marine protected area and how to key in on certain areas. But when the tide changes, you can see sort of the dramatic whirlpool sort of out of Odysseus. And that's a fluorescein, a non-toxic dye, where we were looking at connections between inland and offshore. That was, I thought I would be smart to take off my dive gear and just breath hold dive it to lower resistance, and it sort of sucked me into the hole. I won't go into the psychology of being sucked into a blue hole, but it did take my camera, and oh, good, I didn't know if it was stuck or not. But you can see the volume of water that it's pulling down. And again, I don't want to underemphasize how quickly you can have saltwater intrusion happen with just a little bit of a change in the sea level rise. We can lose giant freshwater well fields. Where we live in Florida, it's a constant battle between population growth and sea level rise to keep our fresh water intact. Again, in addition to sort of the current but longer term big threats of sea level rise and other associated climate change, precipitation changes, we've just got pollution. We tend to out of sight, out of mind, so it's a hole in the ground. That's where a lot of garbage goes. Certainly pesticides, fertilizers are a big challenge. Land surface uses are a big challenge to our groundwater. And again, what affects the groundwater in these coastal areas ends up affecting our reefs, our mangroves, our habitats. Some of the endocrine disruptors associated with birth control pills or with SSRIs, these are all showing evidence in the marine ecosystem, and they're starting off through these freshwater systems. So through leakages and inefficient, we're really not good at filtering these out, and we're seeing it all over the world and seeing effects physiologically, as I'm sure many of you know. This is about 500 meters into a cave, and there's plastic bags kind of floating on the stuck on the walls. There's 55-gallon drums. There's tractor tires that are pulled in there in those dramatic tides that I was showing you before. And right past this picture, I'm sorry I didn't get it in the picture, but I'm floating above a pipe that's going right to someone's well directly for their drinking water. So it's a human health issue, and it's, in our part of the world, it's very much an equity issue in who has access to fresh water and who has treated water. I know I'm talking about some of the scientific or the global public health issues, but it's an amazing otherworldly environment that's right beneath our feet. This is a picture where you can see, and these pictures I should mention are from my mentor and photographer, Wes Skiles, who died. This was a lot of this is part of a National Geographic project about a decade ago, and he died right before actually the cover story came out. So I feel like I'm up here telling a story that he was, had been his story that he'd been trying to push globally for a long time. So I'm honored to be up here for that reason as well. But it's this inner space that we're working in, and it's hard to describe. Some people talk about it as peak experiences. Some people talk about it as you really lose yourself when you realize, what we have around us on this planet and the fragility. And it's even reinforced when you think about that we're swimming through our very, very finite source of drinking water. So just briefly in the last few minutes I have, I just wanted to talk about some of the scientific findings that we see in these areas. A lot of the areas we may only get 1 or 2 dives in before they might be silted out for weeks on end. So some of it is looking at different creatures. This is a professor that I work with, Tom Iliff, who's one of the few cave diving marine biologists. There's all sorts of cave adapted creatures. This is a blind cavefish. Blind crustaceans. Why put any of your evolutionary energy into pigmentation or into trying to see? Here's a shrimp. You can see the eye but no optic nerve, so we know that it probably evolved out of the ocean into a cave setting. This is actually a new class of crustaceans that was found in a cave called Remipedia back in the 70s, and now there's very interesting that they're also found in the Mediterranean and parts of Central America, the Caribbean, with very similar genetics. And we know from, if we go back millions of years to the Tethys Sea, we know how some of these connections were probably, how these species probably originated out of. Here's a video of collecting. Sometimes cheat with a big plankton net, and you'll see that we often use rebreathers in some of the areas that have critical biogeochemistry because we don't want to introduce oxygen. Oxygen is toxic to a lot of these creatures. That's about as big as they get in terms of these crustaceans. And for those of you with OCD like me, this will drive you crazy, as it has done, and I've seen this 1,000 times, and I still can't watch it. And I'm still going crazy. Okay. We work with a lot with, again, astrobiologists. This is work we did. This is in about 180 meters of water. And these are some of the ancient microbial mats that we then bring up, and we usually have a lab in the field. We work a lot with Jennifer McAlady from Penn State University. He's a geomicrobiologist who looks at some of the, remember it's not photosynthesis, it's chemosynthesis, and all sorts of other ways that these extreme forms of life can sort of stay alive. I'll mention briefly that, again, anoxic, no oxygen, salt water is great for preservation. This is an ancient owl roost. When sea level was lower, the owl would go out and hunt during the day, come back. Owls can't metabolize the bones, so they would cough up all these bones. And we got, I think, found about 18, 20 species just out of that one excavation pit, including species that either are extinct, we didn't know lived in this part of the world, a rare crocodile that's now highly endangered. There's no living descendants of people from this area. The Lucayan Indians were actually reburying a skeleton that was taken out illegally out of one of the blue holes. 5 minutes, no problem. Amy touched a lot on the climate record and what we've learned from it. And this is where we get a lot of our climate record from the stalagmites. Those are the ones that grow from the bottom. And we bring them back to the lab, you date them with uranium, thorium techniques, and then look at the oxygen and carbon isotopes. The other aspect that was very surprising on a recent expedition that sort of changed the direction of some of the focus in climate studies is massive amounts of Saharan dust that coincide in the climate record with Heinrich events and abrupt cooling, and then into abrupt warming events that have a big effect on ocean circulation that we were talking about earlier. Here's a satellite image of that Saharan dust coming off right now. I think we all know that's why we're at this conference, the implications for climate change, and there's a lot more questions and dust questions as we think about some of the discussions we can have about future research. Just to wrap up, and a lot of what we do, we try to tie to working with local groups, particularly with education, because we're so disconnected from our water sources, where we seem to think it magically comes out of our tap. So we try to bring exploration and activities to the different areas we go. This is radio tracking some of the divers while they're down beneath, and just to give you a flavor. And a lot of this ties into working with local governments. So actually, some of the areas where I showed a lot of the pictures is now a conservation forest, and to try to maintain that fresh water, or the hydrostatic head, because the larger the body of this fresh water, the more we can sort of slow down the impacts of saltwater intrusion on sea level rise. So I'll skip that video, but I'll just end on this image, which is from the US Geologic Survey. That big blue marble, that's all the water we have here on Earth, fresh water, salt water, all combined, surface and groundwater. I don't know if you can even see that second little marble. That's 95% of that is groundwater. And again, it's something it doesn't have the charisma of our surface waters and lakes, but again, it's critical for our survival. And I know probably Israel is the model for how we can make the most of our limited resources. And but I thought I would try to tie that to our saltwater challenges as well. So I'll end there, and if I still have time for some questions, right?
Let's skip the questions. You don't get to go away yet. Okay, first of all, amazing. Every time I'm seeing new images, new videos, it's just unbelievable stuff. We have a few minutes for questions to open from the audience. Any of my students want a cave diving specialty in the scientific diving program?
Good job.
Maybe not after those videos.
It's good job security.
Any questions? Is there endemic development of species? The geneticist asked.
Yes. Is there endemic development of species in the blue holes? It's one of these areas that we get such brief glimpses into, and it's very hard to keep these creatures alive outside of their environment for long periods of time, that it's hard to tell if it's the short answer is yes, just because we have regional differences genetically, but we don't know enough about the sort of population dynamics historically to know what's going on. And it's the general consensus is that most of these species have not changed much over about 200 million years of the crustaceans. That's the I guess that's what I meant by the comparative regional, if we're saying the same thing.
More questions? Ah, yes.
Climate change in the...
Yeah, in the holes, are you seeing effects? Sea level rise, things like that, how is that? Is that altering?
In terms of, you see the effects of sea level rise, you can reconstruct them historically, but in terms of modern day impacts of climate change, so it's using the stalagmites, some sediments, you can reconstruct more extreme events, such as what were hurricane patterns in the past. And with the stalagmites, you can see climate change on annual resolution, looking at carbon oxygen isotopes. In this part of the world, we've gone back about 350,000 years, and so we're able to compare the record from these caves, for example, in the Bahamas, to more global records of proxies. We actually know a bit more about before the Holocene, so we're having trouble actually finding stalagmites, stalactites, and records from the last 10,000 years. But before that, on annual resolution, we can reconstruct the climate. And you can see these extreme climate events that I was referring to, such as Heinrich events, where within a period of 50 years, you can go into rapid cooling and then into warming. It was sort of what was the Hollywood version of it, was what was the Day After Tomorrow movie. And it's, again, related to ocean circulation that we heard about earlier this morning.
Thank you so much. Thank you.
Okay.
So at this moment, I'd just like to, first of all, acknowledge and thank Tzili Charney for the school that Leon Charney helped to establish. And also, we have an honored guest today, Senator Bill Cassidy has joined us. Very much appreciate that. And he didn't mean it about the slow decision making. That was, he he wasn't trying to pick a fight. It's, That's true. Well thought out decision making that happens. That's what he meant to say. And the Board of Governors, thank you for coming. Now, in order to stay on your schedule, if this would be the time to leave the auditorium. You are invited to head out to your next event, and we will then bring the next speaker. So, Akos, do you want to introduce the next speaker?
All right. So moving on now, and we are going to see and hear a recording by Dr. M. Jackson, who is a National Geographic explorer, by Dr. Beverly Goodman's introduction inside the video.
I'm really pleased to be here to talk about a headline issue of our time, the changing climate. But to add,
Thank you so much for having me. I want to start off by telling you a story about glaciers. Years and years ago, I was doing fieldwork on the south coast of Iceland, and one day this stranger knocks on the door of my house, and he asks, "You're a glacier researcher. Do you want to see something?" But he didn't give me any.
Hi again. So video is coming afterwards. Now we're going to skip the video and moving to our next speaker. I'm proudly introducing her once she saved me and my samples from a flash flood I was sampling back in my PhD. She's a coral biologist here at the University of Haifa. She studies the basic mechanisms responsible for calcium carbonate precipitation in calcifying organisms, specifically in corals. She targets her study on how corals respond physiologically and morphologically to rapid environmental changes. Please welcome Professor Talimas.
Okay, so thank you for inviting me here. Bev was asking me to talk a little bit of how climate change looks from a point of view of a coral. And I was trying to put something together, and for that I will try to first explain you what is a coral, and why we are so excited from that. Except for the part that they are beautiful creatures and that we all love diving and seeing them underwater, they build up the most important bioconstruction structure in the world, which is the coral reefs. These coral reefs can be seen out of space as well. You can see the Great Barrier Reefs and other structures like this. They actually buried amount of calcium carbonate within this structure, so in a way there is sink for CO2, and they produce more than 10 teras of kilograms per year. And at many places around the world, the coral reef serves as a major food source for the local population. They protect our coastlines, from tsunamis events, for example. They act as natural barriers. They are a very important economical source, so few governments, so depends on those economical sources from tourism point of view, and you can see the numbers here on this place. And from the paleoclimate part, they also can be sourced for reconstruction of the climate. And today we're also trying to look for medical remedies, as those creatures lived here way before us and survived so many things, and we sure that there is a lot of aspects to find over them. With corals specifically, we can people start using them as bone implant, for example. And all of it starts from this little creature over here that you see. So this tiny polyp over here, this is the first polyp of a coral that settled on the ground. And within a few years, it will build up, him and his friends will build up this huge structure that we see from space. And this is actually an animal, and you can see here his mouth. From here, you can catch out these little particles and little zooplanktons that you can see over here. They have tentacles that host these stinging cells. They are the same family as jellyfish, and they sting they can catch their prey. But they also have symbionts within their structure, and you can see here the symbionts here, that this symbiosis relationship within corals and algae produce increase this rate of precipitate their skeleton that we can see over here. However, there is a lot of damage or a lot of destruction that we, in general, a natural part can affect those reefs. As those organisms are sensile and they sit on the ground, they cannot move anywhere, they cannot run from floods like you were saying, or they can, or for pollution that we are throwing into the water. And we can divide those pollutions into two factors, the biogenical factors, natural factors like storms, and we saw in the first talk today the huge hurricanes, they're affecting also those coral reefs in different areas, not in our areas. We also have some local storms. This is the results of a local storm that we had here in the Red Sea. And the global warming, ocean acidification, and on the other part, on ours, from the human part of it, the anthropogenic stress that we're putting on those reefs will be the collection that people really love for some reason to have them on their shelves, and buying them from places around the world. There's fish trades and also pollution that's been poured into the water, as we saw from these sinkholes that was presented before. I'll concentrate in this talk on two examples of that related to global warming and ocean acidification, as we know that those are the two major factors that might affect the decline of coral reefs, and we see today more than 50% decline in coral reefs covers, mainly due to temperature. You can see here temperature event in the high temperature event in the Great Barrier Reef that results in huge bleaching. On the other side, we see that CO2 sips over here, although the acidification of the water predict to decrease within the next decade, here we can see corals that actually live in areas of natural CO2 sips. So although those, despite all the ecological importance of coral reefs, we still don't know much about the molecular and physical pathways that underlie this amazing creature and how they actually build this skeleton. And this is what we are trying to understand in my lab. So let's talk a little bit of ocean acidification and how it looks from this, from those creature point of view. So here what we see, and we saw this before as well, that the increase of CO2 gas in the atmosphere reflect also into the ocean. So this is the CO2 in the atmosphere. You see the increase of the levels from the end of the 19th century, and in the water you see it here parallel, following the same trend. And on the other side we see the decrease of pH in the water. So those creatures build a limestone, and just before me, Kim was talking about the acidifying water and how it affects calcium carbonate. So we all know that if we put a drop of lemon something on limestone, it will dissolve. And that's a prediction of those cores, that's what might affect the skeleton of the coral. And we can see here a prediction that as the PO2 increase or the pH decrease, the precipitation of calcium carbonate will decrease as well. We saw also evidence in skeleton, and this is a work that done in Monaco a few years ago, and showed that as the pH decreased, the skeleton become more porosity, something more like osteoporosis or something for skeleton. However, when we look at the geological record, and here is a geological record from the initiation of corals 250 million years ago, and each one of those lines represents a different coral family. And we can see that those families actually in this area, this period of time, they disappeared, but mostly we see them staying and consist throughout this geological history, even with 3 major extinction events. And we can see here the 3 major extinction events. We will talk about this one that was happening like 55 million years ago, and at this period of time, the Paleocene thermal maxima, we see a temperature increase in the atmosphere much more than what we're today, and the pH decrease more rapidly than what we expect today, and we see that those corals, some of the corals survive. So those corals probably have some kind of a mechanism that enable them to survive through different period of time. And we're talking about geological history, we're not talking about our own time frame, but in long term, we think that we anticipate that something that within their genes helps them to survive. And what we did here, and this is a work of my PhD student, we tried to do a holistic way of thinking. So we investigated the coral, both physiology, ecophysiology, the skeleton structure, and genetic structure. In all of those to try to understand if those corals will be able to survive in different pH. For the ones of you that don't know, we have here in Haifa a huge aquarium system that was built here in order to be able to mimic different ocean scenarios, included pH. So we run all those experiments here. We collect the samples in the sea and we bring them up here to Haifa. And after 10 days or so of growing, and this we start from the initial babies, the one that actually they didn't precipitate any calcium carbonate, and they start growing the skeleton as they settled. And what we saw is that there is some kind of a balance between the corals that grow in a low pH. This is a very low pH compared to normal condition. So they breathe much less. The metabolism is much slower. They slow down their metabolism. On the other hand, they increase the amount of proteins within the tissue. When we looked at the skeleton, we saw some interesting skeletal features that changed with the different treatment, and I will not go into all the details. And we also looked at the genetic parts. And here we know we already have a list, or we already established a list of genes that we know that related to the production of calcium carbonate. And as the color is more blue, those genes are downregulated or not active compared to the green one in the different pHs. And one thing that we saw is that there is a group of protein that we know that initiate the calcium carbonate precipitation, and this is the one up here, that stop being active in a low pH. On the other hand, other proteins, that all the red ones that we see here, they have a role in building a structure, more like a collagen structure or something like that we have in our bones, and those are much more active in the low pH. So this is the imaging that we created in 3D imaging of those two corals, and you can see here the low pH and the high pH corals. We conduct those researches in high-resolution synchrotron imaging in Europe. We build up a tomography data on those corals, and what we can see we can see really the different areas of the skeleton, and the one that shows in red, those are these centers of calcification where calcification actually starts, and you can see that those centers are lacking in the low pH. So what we found out, or what we established, that there is some kind of counterbalance between the two conditions. So the low pH, at the low pH we have less skeleton, but on the other hand, we see more organic matrix formation in order to reach to maturity, and we see higher tissue biomass. It's a little bit similar to what Danny in the past showed in the coral that lost the skeleton but continue to live. So in a way, they have a way to wait until something will change, but because they know the genes are less active, but once the situation will change, they will be able to resume the calcium carbonate precipitation. But what about temperature? Or what about the different, the effect of temperature on corals? Here we know that there is much more dramatic effects on coral. With the increased heating events that coming up in the past years or so, we see more and more rapid events of high temperature that results with large coral bleaching. And you can see it over here. One of those places that suffers such a condition is our Mediterranean. The Mediterranean is a small enclosed basin that slowly temperature is rising there slowly, and we saw it today in the first talk. And even though it's a cold water area, it's a climate area, and it's not coral reef, and it's not known as a coral reef, we still have corals here. And every time I approach to the Mediterranean and start talking about the Mediterranean, the first question that I get is, are there really any corals here? So yes, we have corals over here. And here you can see the amplitudes of the temperature, and you can see that it reached to 31 degrees, and in the winter it reached also to almost 11 degrees. Definitely not the temperatures that coral likes. But the coral we see over here is this little brownish dull coral that called Calina patagonica, and it lives mainly in the shallow area. It's a very strong and robust coral. During the summer, he loses all his symbionts, and in the winter, he gains them back again. It has no problem with seasonal bleaching, so it's a great coral to study. And a lot of the people that have been in our courses, you know that we like really to study this creature. However, recently, in part of the MOISCAN monitoring program, in the last about 5 years ago, we started seeing this coral in an area that was not what we were not expected to see it. We saw it down at 35 meters, and instead of being in caves like we saw it in the shallow water, we saw it on top of rock structure. And here you can see us diving in these areas. We also use rebreathers, but in other areas, and we start seeing this coral over here. This brought us start our assumption that maybe something happening here. A coral that we know that lives in shallow area, suddenly we see it in much deeper area. And if we go back to this graph, you can see that there is a large variation between the two sites. So in red you see the shallow area, and in blue you can see the deep area where we see these corals, and you can see that there is at least 2 to 3 degrees difference between the two sites. So in the deep water site, we see temperature that resemble what was here a few years back. So what we started looking, we looked again at what we already know, at the structure that we know. We looked at the two corals, and you can see here the two corals from the two different places, and we couldn't find any differences between the corals, not in the morphology, and you have here all different color parameters that we checked in morphology. We couldn't find any physiology differences between the two. We saw that the chlorophyll was the same. We saw everything was similar between the two sites. And we couldn't understand what's the story here. So one of the things that the next thing we tried to check was what's the light level between the two areas that we usually see these corals. And using light meters, we set the two areas, and in the shallow water, we usually see them in caves, and over in the deep water, we saw them facing to the surface, and we actually realized that they sit in the same light environment. The only difference was the temperature. So from that, we're suggesting that maybe there is a possibility that those creatures migrate deeper to avoid this hot rapid temperature that shallow water face, and maybe they're waiting for the next stage or try to adapt as well. To remind you as well that migration of corals is slightly harder than people. They don't move so fast. but still we see it over here. So with that, I'll thank my lab and all funders that fund our work, and we'll be happy to answer questions if there's.
All right. So we're covering blind fish in caves and quiet corals. We'll start with some questions. Would anyone have questions for Professor Moss?
No.
Sorry.
So, no, we didn't observe any changes of folding, protein folding, mainly because no one still did any protein or three-dimensional protein structures in corals. It's not that trivial to get the coral proteins out. The corals that related to biomineralization are very acidic, and they don't have any predicted structure. So that's one of the main problems with those corals, with those proteins. But we did see changes in expression of the different proteins.
More questions? Kenny.
Okay. Is there much discussion of assisted migration as a proactive management measure in the Mediterranean?
Not that I know, and I don't know if that's the place to start with assisting migration, because then we might change the whole ecosystem into a different place. They do it naturally, so they can survive in different places. We see migration not only in the Mediterranean, and there is a large prediction that maybe the mesophotic reefs can serve as a refuge for shallow waters. This is another aspect that we're studying a lot in my lab. However, we don't look at the part of assisting migration. That's a whole different question that relate to different subjects as well.
Any more questions? Okay, we have a little bit of a surprise, even for you. We're actually going to do, if it's okay, we're going to do a panel. We've been having technology issues, as you know, throughout the morning, and they're going to be resetting the video. So before we do the flash talks, we're going to invite the speakers to return so that we can have a bit of a panel conversation and Q&A with all of our speakers. Ilana, do you want to join? Would you like to? Yeah, well, you can ask your question. Please contribute some questions from there. So feel free to come and have a seat.
Now we feel like resting.
Some of the marine areas is some of the areas that are oligotrophic, that don't have a lot of nutrients. They're actually getting nutrients from agriculture and fertilizers. So you're seeing some biodiversity hotspots in some of these cave entrances that you wouldn't expect to be there, as well as in areas that are warming. It's a little bit cooler because of groundwater and the more nutrients. So we're seeing some corals in areas that you wouldn't expect, but I think that's a small patch compared to the global problem.
Small silver linings. Okay, so thank you so much. We're now going to go back to our program with M. Jackson's talks. Right. Thank you.
All right, so the video is working. And the next one, please enjoy the recording by Dr. M. Jackson, a National Geographic explorer.
Thank you so much for having me. I want to start off by telling you a story about glaciers. Years and years ago, I was doing fieldwork on the south coast of Iceland, and one day this stranger knocks on the door of my house, and he asks, "You're a glacier researcher. Do you want to see something?" But he didn't give me any adjectives, so I kind of considered for a minute. But then I grabbed my jacket, hopped into his truck, and we drove for an hour until we got to a local glacier, Bredamerkejogult. Once we got to that glacier, we hiked about another hour till we got to what I thought was our destination. This place that had flat ice and then a bowl We hiked down to the bottom of that bowl, and I remember looking up and seeing these seracs. Think big chunks of ice that stick up like shark's fins. And my host, he hands me a cup of coffee and he says, "We're gonna wait." He really wanted to show me this thing, but he wouldn't tell me what it was. He just said, "We're gonna wait." So that's what we did. We waited for 20 minutes, and then another 20 minutes, and then 1 minute it was dark, and the next minute it wasn't. The northern lights, the aurora borealis, they began to blaze, these yellows, these pinks, these greens, shooting through those thin seracs. This bowl of bare ice that we were sitting in, it lit up like a chandelier. Me, I have been researching glaciers for decades, and I never knew something like this was possible, to stand inside glacier light. It's these types of experiences that I think about, that weigh in my brain as I work with glaciers around the world, as I work as a scientist, as a writer, as an explorer. It's these things that I try to keep in mind, that glaciers, they help us redefine what's possible. Today, we have some 5.8 million square miles of ice, over 400,000 glaciers and glacierats. And we have glaciers all over the world, in the Arctic and Antarctica, in Europe, Asia, Africa, pretty much all over the world except Australia. And here's the thing. Everywhere glaciers are located, they are located in inhabited and historic environments. Where there are glaciers, there are people. And the two have been interacting, influencing, transforming one another for the entirety of human history. But we actually don't know all that much about people in ice, because for a long time, we didn't think to look. Glacier-centered research, especially today, tends to focus on the metrics of glacier ice phase change, of ice to water, to what happens as our ice melts and our oceans respond by rising hundreds of feet in our predictions. And this research, while incredibly valuable, gives us a significant knowledge disparity, a blindness to how people in ice transform, especially today as the ice itself is transforming. Let me give you one example. For years, I've been working on the place on your screen right now, the island of Iceland up in the North Atlantic. This is a place that has been intimately linked with glaciers since the island was first settled well over 1,000 years ago. I think that there's about 400 glaciers, about 269 of them are individually named. And I've been working with all of them, but mostly down on the southeastern coast. I've been working on this place where there's about 30 outlet glaciers that cascade down onto this 125-mile narrow stretch of land that's of ice between the North Atlantic to the south and Vatnajökull, the ice cap, to the north. Here in this place, people have glaciers right in their backyards. But like glaciers worldwide, the glaciers here in Iceland are melting quicker than ice has ever melted in human history before. Local glaciology models, they predict that Iceland's glaciers are going to lose about 25 to 35% of present volume over the next 50 years, largely as a result of increasing climatic changes, here most specifically, increasing air temperatures. So that glacier I talked about in the beginning, the one I saw in a chandelier, that's the one on your screen right now. How does this glacier respond to increasing climatic changes? Well, between 1982 and 2020, 3 miles of this glacier's physical body have dissolved away into the ocean. That's massive phase change from ice all the way to water. And for the last couple of decades, I've been coming to this glacier, not only to monitor its unique recession patterns, but also to see how this glacier shows up in the local community, what those connections are and how they're transforming. So look at this image and look at the bridge in the middle of the image where people are walking across. Think about this. Where that bridge is in this image, this was a place upon Iceland's settlement well over 1,000 years ago. Right here, this was once rich, vegetated meadow and thick birch forest. When the Norse settlers arrived here over 1,000 years ago, I imagine they looked around, they thought they hit jackpot. They immediately started to raise farms, families, futures right here. Look at this place. On the screen, it's so gray. But when I'm here, I walk around and I think about how livable, how green it all used to be. That is, until the planet's climate started to cool, started to shift with the Little Ice Age, and how up valley from where you're looking at the screen, the small little glacier Breithermerkjogel started to respond to the changing global climate, started to respond to those cooling temperatures by growing, by getting bigger, by starting to advance down valley to where those homes, those farms, those families were. Look in the center of the screen and you'll see a little farmhouse, right? This is what it might have looked like with different circumstances when those Norse Vikings were still living right in front of Breithermerkjogel. Because during that time of the Little Ice Age, the glacier, it seesawed back and forth, grinding everything down in front of it like sandpaper, causing those people who lived in those farms to go out every day, turn around, and look at where that glacier was and make a decision. Do they go or do they stay? A decision that's actually rather similar to the decision people who stand on the edge of the Mediterranean, who stand on the edge of the Rio Grande, who turn around behind and look at a changing environment and make a decision. Do they go or do they stay? Here, these people had to flee because the glacier Breithermerkjogel, it just grew bigger and bigger and people fled before it because they could no longer live here. This ice actually grew so big that it pushed down, it weighed down the Earth's crust. The whole south coast of this island, where people once moored their fishing boats, where they had safe harbor, this whole area, these fishing grounds, they sank, they subsided, and the North Atlantic Ocean rushed in and covered it all. But fast forward in time to the end of the 1800s, when the Little Ice Age completed, and the glacier began to respond to the stress of increasing climatic changes, this time warming temperatures, by receding. 1 step forward, 2 steps back, 2 steps back, 3 steps forward, 5 steps back, and Icelanders, they saw this, and they started to move back into this area, mooring their fishing boats in those newly exposed harbors that were rising out of the ocean. They started to raise again their farms, their families, but this time only building on high points, because they knew that glacier would grow bigger and move forward again. It always had before. But jump forward in time another century, and the ice hasn't behaved at all like it used to. Climatic changes have pushed this glacier into a backward march towards gone, deteriorating quicker than ice has ever melted in human history before. I today have sat across countless kitchen tables drinking coffee so thick you can chew it. And I have had Icelanders tell me that they fear glacier recession, that they fear the ice is going to melt all the way down to the last snowflake. And they ask me, can you still be Icelandic in Iceland if there is no ice? So when we talk about phase change, ice to water, we have to think in what ways might historic identity, present identity, future of identity of an entire people, how does that change as our ice changes? I've also walked across farms here with local people who tell me that they are grateful that the glaciers are getting smaller, because that means the glaciers will no longer surge across the land all the way to the ocean and destroy the farms and families and futures that it had done like it had done over and over again in the hundreds of years before. These people, they tell me there might be safety now, that their perceptions of climatic changes, of hazards, stretch back to include hundreds of years of previous experience. So we have to think about what is this phase change of ice to water, and how our perception of it shaped by the histories we live in. I've also been out with people who laid bank statements down on their dining room tables and explained to me that as glaciers melt, they melt money. Because millions and millions of tourists in pre-COVID times, and then of course as COVID is finishing, millions of tourists come to Iceland to see the glaciers before they're gone, what my colleagues call last chance tourism. And in this region of Iceland, bank accounts are filling up as locals run glacier tourism companies and open hotels and restaurants. And people tell me that for the first time, they finally found economic stability in this area, something they've never had before. Because of climatic changes, because our planet's glaciers are melting. And I've been out on fishing boats in this whole area listening to fishermen tell me that they fear for this region because they know instability is coming. The glaciers are melting and the land keeps rising via something called isostatic rebound. And now the best fishing harbor on the south coast is too shallow. It's too full of sediments, and fishing boats and tour boats can no longer get in and out of this area. And locals tell me they fear the economic instability that is coming as the land keeps rising and the glaciers keep melting. For years, I've been walking across this glacier with colleagues, with friends, with locals, and just like all of us are trying to make sense of the changes in our backyard, so too are these people. This is what I think about when I work with glaciers in Iceland or glaciers worldwide. What to me is so clearly powerful about ice. Glaciers make visible things that can seem abstract, like senses of identity, spiritual or cultural values, economies, senses of safety, how we understand phase change. This glacier on your screen right now, Breðamergjökull, it is one glacier out of 400 in Iceland. It is one glacier out of the 400,000 worldwide still in existence today. This is something to pay attention to. All of these different stories for one glacier. So what happens if we start looking at the stories of all of our glaciers? I wonder what glaciers might teach us about living in a transforming world today if we started paying attention and we started looking. Thank you.
Thank you, Dr. M. Jackson, hi from Israel, for the recording, and thank you for the crew for making this recording available. So right now we are moving to our last part of this session, a speedy session. You're going to hear another 4 flash talks, 3 by students. And these students prepared not just these 2 minutes flash talks, but also a poster and a 2-minute video that summarizes their researches. And those of you who are watching us online, I encourage you to go and browse on those videos. So first of all, I would like to ask Alhan Abu Hamoud from University of Haifa. Afterwards, there will be Catherine Mersey from Area University, followed by Orzion Levy from University of Haifa. And then you will hear a presentation of a program, an honors program, and then you will hear those 2 videos from the previous section. This is not that one.
Mm-hmm.
Click on
It's not that. This one? Ah, it's here?
Yeah. Right.
Nice. Hi everyone. Are you hearing me? Yes. Okay. It's very nice to be here. Okay, hi, my name is Alhan Abu Hamoud, and I am a marine biology master student in Laura Sterle's lab. So my question to you is, have you ever thought that a small bacterium can be contributing to the global warming? And if we want to talk about oligotrophic oceans, so we are talking about low nutrients, oceans with low nutrients, meaning that microbes and organisms need to find ways to survive despite these harsh conditions. And sometimes the solution they found have also indirect consequences. And if we want to talk about my topic, so my research is on cycling of methylphosphonate, which is an important source of phosphate when inorganic phosphate is limited, and which is very nice. But interestingly, when this methylphosphonate is degraded, the bacteria don't get only phosphate from this, but also methane, which we know that methane is a greenhouse gas, and the greenhouse gases are causing increasing in temperature, which lead to ocean stratification, and this will cause more phosphate limitation and further methylphosphate degradation. And going back to the small bacteria that we talked about, so we are talking about SAR11. SAR11 is the most abundant marine heterotrophic bacterium on Earth, and they may play a role in this vicious cycle via methylphosphonate biosynthesis. So we postulate that some SAR11 strains are responsible for most of methylphosphonate biosynthesis in ocean. Our aim is to test this hypothesis and to try to investigate which environmental conditions trigger this methylphosphonate biosynthesis. And if you would like to hear more, so you are welcome to visit my poster and we discuss everything there. Thank you.
Okay, so we all know that plastic pollution is a big problem, but did you know that there's so much plastic in the ocean that it's considered its own ecosystem? We call it the plastosphere, and it's distinct because the organisms that live on the marine plastic debris are different from that of the surrounding waters. I'm Catherine Marseille, and I'm a postdoc in Matan Oren's lab in Ariel University, and together we investigate the bacteria, eukaryotes, and fungi that live on plastic debris in the oceans. We hypothesize that organisms that show a preference to plastic may contain genes, enzymes, or pathways that have adapted to attach to the plastic or even degrade the plastic. We collect both experimental and environmental samples. For example, we set up a mobile of different types of plastic and placed it in Hertzilia marina. Using glass as a control, and differential abundance, we were able to identify 35 organisms that had a preference for plastic. We also collect environmental samples off the coast of Israel. We've been doing this for 2 years now, and we also receive samples from our collaborators in Portugal. This allows us to analyze the location and season and this effect on the plastosphere. We've noticed that location has the most effect on the variation of the organisms and then season. And in fact, we propose that there's not just one ecosystem, but many different ecosystems, and it depends on many different environmental factors. If you would like to hear more in depth on my results or methods or see some really nice microscopic images that we took, please come see my poster.
Hi. Okay. AUV, autonomous underwater vehicles, have become very popular and are frequently used for oceanographic surveys, mapping applications, and many more. The AUV enabled reaching depth and scanning areas at scopes we couldn't imagine before. Navigation, which actually means knowing where you are at any moment, is one of the most basic capabilities for any autonomous vehicle. Although navigation is a well-known problem with many methods, underwater navigation is challenging, and it lags behind the land or area navigation capabilities. This is mainly because of the lack of available aiding sensors, as global navigation satellite systems like GPS are not available deep underwater. DVL, the Doppler velocity log, is a reliable sensor widely used for AUV navigation systems. It measures velocity relative to the seabed without needing prior knowledge or compatible infrastructure, making it available in almost any scenario. We propose an algorithm that better utilizes the DVL measurements by estimating the acceleration vector based on past DVL measurements and using it to enhance the INS, Inertial Navigation System, and DVL fusion. Simulation results show that using the acceleration vector is significantly improved navigation performance, and C experiments to validate the proposed approach were already made using the Snapir AUV and soon be analyzed. Considering the limited number of sensors and the common use of DVL for underwater navigating applications, an algorithm that improves and maximizes the INS and DVL performance is essential. Thank you very much.
Hello, I'm Rem Neri, and I'm going to talk about mining social media for last mobile fishery data in conflict zone using the Gaza Strip as a case study. Conflict zones are categorized with terrestrial disputes, military conflicts, and encompass large swathes of coastal regions, which suffer from unsafe or impossible access, no regulatory agencies, no international repercussions, and rapidly changing landscape. This causes a major gap of environmental data available for research. Our study site, the Gaza Strip, is in intense conflict in the last decades, during which access to marine areas is often restricted, and the only catch estimation is by self-report by fishermen. Located at the eastern Mediterranean, the Gaza Strip was known for a bountiful fishery since ancient times. In the last decades, marine blockade and bathymetry influenced catch. A last mobile catch was never detailed and described to specific groups. Lack of ice and refrigeration pushes vendors to use real-time broadcasting, in example Facebook Live, to advertise their merchandise. Using these videos, we can manually log important fishery data such as date, time, specimen count, vendor name, price, location, and sometimes also the sex of the specimen, total length, disc width, and weight. To this point, we have collected 584 data points in which rays and sharks are being photographed as daily catch in the Gaza markets. The largest fish group in this period were 2 species of guitar sharks, 2 species of rekin sharks, followed by stingrays and hound sharks. As for temporal distribution, we see more conformity after the extending of the allowed fishing zone between 15 to 50 nautical miles after June 2021, which afterwards we see a similar distribution of catch every month on the right side. This is believed to have to be in a connection to increase fishing depths to where certain species are known to use as habitats. Thank you very much.
Hi, my name is Semyon Polinov. I am a PhD student in the Department of Marine Science, University of Haifa. In this presentation, I want to present you the results of study of spatial interpol analysis of oil spills in the Mediterranean Sea. About 50% of all petroleum reaching the marine environment is human produced, while natural processes such as geological sieves and earthquakes account for the rest. The ecological impact of natural oil sieves is limited given their steady input rates. In contrast, the shipping industry is a major contributor to catastrophic and chronic marine oil pollution, given the large volumes of oil that can be released at a single event and chronic pollutions. The most common means for remote oil spill sensing is to use optical and radar observations of the sea surface to detect and map oil spills. In these 2 images, you can see the use of 2 types of satellite images that allow us detecting and tracking oil spills on an example of coastal spillage accident that started last year in August 2021 and still continues from Banyas refinery factory. Using relatively simple image processing techniques, marine pollution events can be identified and validated with high accuracy. In the right image, you see the distribution of oil spills affected by satellites. High concentration of oil spills were located farther away from the coast, in the deep sea areas. In the left image, you can see the distribution of tanker oil spills, which spillage higher than 7 tons. Based on reports, the Mediterranean coastal zones were exposed to higher concentration of tanker oil spills than deep sea areas, apart from episodical accidents in the deep sea. Conclusion of the research are: shipping the main source of marine oil pollution. 90% of tanker oil spills occur close to the coastline, and the main concentration of delivery discharges from ships is located 22 to 100 kilometers from the coast. In the last 20 years, the number of oil spills from tankers has significantly decreased and approached 0 spills annually, while delivery discharges stayed stable or even increased. Levantine region, hotspots of delivery oil pollution from vessels. Remote sensing effective technology for monitoring marine oil pollution. Thanks for your listening.
Thank you for these excellent talks and video recordings. Now we are going to a break. We're going to have a lunch. But before that, I'd like to remind you that the presenters are going to have posters, so you will have a chance to ask them and have an informal way of communication and talking about their researches. We are trying to keep this conference as eco-friendly as possible. Thank you. And Debbie's going to say a few words about recycling and kinds of stuff. Thank you.
So in order to reduce part of our waste here, it's not 0 waste, but we are trying our best. We have Omel from Save It, and Omel is going to come here, and he will explain about the different, the cups and the trash and how does it work in the compost. He will also be giving a flash talk later, but this is just so you're aware about what's happening when you're disposing of your trash later on. Omel?
Hi.
Microphone.
Can I talk without the mic? Can you hear me? Or, yeah. So hi, how's it going? My name is Omer and I have a company named Save It. We provide zero waste to landfill solution. Debbie said we're trying to do it zero waste. So our belief that in the capitalist world, it's really hard to reach to zero waste. So the professional terminal waste management world is zero waste to landfill. So just short brief about lunch and the waste management in this event. All single-use items, including this cup, are compostable. biodegradable, and we collect them in special bin that you saw outside. And from here, we're going to take the compostable single-item products to a special compost facility that's going to be, from the beginning. We're going to take all the compostable single-use items. We're going to mix them in the compost stream, and then it's going to break down into fertilizer. So my request for you is just to collaborate and separate your waste. And if you have any more questions, we'll be here at during lunch. Thank you.
Let me just make sure with you.
Okay.
Here, we even organized it. You can see it on the presentation mode, but you know what? You have a video with sound, and I want to make sure the lifeguard that we hear him.
Right. And I just want to see the changing over of the slides.
So we tested
You were saying that I can...
So we did it with I think it's with the clicker. Let me get...
Okay.
תן לו במעגל סגור את המצגת. מעגל סגור את המצגת.
Okay. Okay, you have to, okay.
Yeah, that's the only way.
So I have to... No?
Okay, you have to click the screen.
Click which? Here?
Here.
Okay.
Oh, no. I was able to do it here, just from here.
Yeah.
Just right click, left click.
Okay. And say stop it. Okay. Okay. And then to move on. Okay.
Yeah.
So that's the idea. Okay. Okay.
יש לו בתוך המצגת סרטון עם סאונד.
ויש שתיים בלי.
כן, כן. אז רק זה הסרטון עם המציר שאיתמר יודע, מה? כן, שעם המציר, כן.
I'm going to try it, yeah. Here.
Try hit the somewhere inside. No. Inside that.
I hope the multiverse doesn't change from now until you come.
Okay, I'm just trying to see how to get. This takes me on to the next one. Okay. So, wish us luck.
I'm also here and I will jump up on screen.
Okay, thanks. Back, this is forward, this is back.
Mm-hmm.
Right?
Double check that.
It can be in any one, it doesn't have to be in mine.
Okay.
This is forward, okay. And this is back. Okay, got it.
It's American. Perfect. Thank you, Ari.
זה כמו שממשלה חייבת לכבד את ההסכמים של הממשלה הקודמת, אותו דבר הבוסים. ומי שצריך ליצור את זה, זה לא את, זה גליה. סליחה, יש לי, זה הלו"ז שלה. זה בלתי ניתן לשינוי. רוצה ליצור איתה משהו חדש. עלייך ליצור את זה בעצמך, כרגע זה המצב, זה ההסכם שלי איתה. לצורך העניין, עד סוף השנה, זה הכל. ומי שלא עשה את המעבר הזה, עליו את צריכה לבוא בטענות, לא לבוס את החדשה שלך.
אבל יש לי עוד פעם לדבר.
למה שהיא תעשה לך? היא לא אמורה לעשות לך, זה ההסכם שלך. תגידי לך, גברת, זה ההסכם שלי, את רוצה הסכם חדש? את רוצה? אין בעיה, יש לי גם תנאים חדשים, מה זאת אומרת? את רוצה שאני אהיה פה כל יום 9 עד 5? אין בעיה, המשכורת שלי 19,000 שקל בחודש נטו. זה מה שסמנכ"ל נורמלי של ארגון כמו שלך מרוויח. 19 נטו, זה אומר 30,000 שקל בחודש. רוצה? בבקשה. לא רוצה? ביי. עזבי, הכסף לא רלוונטי, אני אומר שהכסף לא רלוונטי. לא רלוונטי. תעשי מה שאת צריכה לעשות, אבל זה לא משנה. כי כסף יגיע, זה לא יגיע ממך, יגיע ממני, זה לא יגיע. אל תתני לך, אז אני מוריד לך את זה מהסרט, בסדר? לא יודע, נמצא לזה פתרון. זה לא משנה, זה לא משהו שאפשר לבנות עליו לזמן ארוך, כן? את יכולה לפתח את הקליניקה שלך בזמן הזה, את יכולה גם, תוך כדי שאת בבית, אז את יכולה לעזור לי, ואז זה עוד חסר במשרה, אז זה מאפשר לי לעשות דברים אחרים, והכסף משם יבוא, במקום שאני אשלם למישהו אחר שיעשה את זה. יש פתרונות, זה הכל, מה שאני אומר לך, זה לא צריך להיות האישו, האישו צריך להיות, קודם כל את צריכה לברר, לעשות את השיחה בצורה ובנגמר. גברת, תקשיבי, יש לי הסכם עם בוסט שלי, אתם החלפתם, הסכמים נשארים, את רוצה לפתוח את ההסכם החדש? אין בעיה, תגידי לי, תכיני אותי. יש לי תעודת הסכם חדש. יש לי. בואי נקבע פגישה, אני אראה לך את תעודת ההסכם שלי. לא יכולה להנחית עליי בדרישות וזה. עכשיו, מי שצריכה לבוא לדבר משהו זה גליה. גליה צריכה להראה לך, תגיד, תקשיבי, לא התקנת אותך, יש לי הסכם מיוחד איתה. עכשיו, אני מבין אותה, היא רוצה שלי, היא רוצה שלי במערכת, היא רוצה כל מה שזה לידה. גם אני הייתי רוצה את זה. למה המעלה מתקשרת עליי? שנייה. אין שלוקי. מה? כן? אז אני אביא לך מתן של אייפון. יאללה, ביי. כן, הלאה. הבת שלנו. עכשיו לגבי אחרי שמתן של אייפון, התרגשתי עד מאוד. למה לא עשו בדיקת קורונה? אוי, נו באמת.
This is the home biogas.
יש לך הרבה להשלים איתי. את יודעת בדיוק מה את צריכה להשלים איתי. כרגע אני שם את זה לזה. ביי. נשים, אתם כזה עם בלתי נסבל. לא, אדם. עכשיו אני גר עם 3 כאלה בבית. עד עכשיו הכל היה בסדר.
מה אתה רוצה שנגן על קבוצת אנשים?
כן? היא חולה אנשים, כן? אבל לפעמים אני באמת עם יד על הלב, הם ניסו לאחת השם הכי מדהימות שקיימות בעולם, כן? באמת. זה ברמה של ראש ממשלה. אבל כאילו, אלוהים ישמור, מה יש לך? מה עם בנימין? הוא בחיים? אני לא מבין. מה, הוא עושה להם? הוא מפרק את הבדים של האוטו? כאילו, הלך לשלוח את האוטו השני, מה הבוקר? הוא יוכל בחוץ, אני תוכל כבר לאכול. בסדר, מה נשמע? כן. כן. בסדר גמור. בסדר. אין שום בעיה, אין שום בעיה. ביי, להתראות. אנשים פה עובדים אחרת, חושבים אחרת, מעניינים אחרת, הכל אחרת.
It is artificial material built on the coastline. We're talking about the fact that 70% of all coastal and marine structures are concrete-based. And concrete is associated in the marine environment with poor water quality, increased and invasive species compared to native species, and lowering biodiversity. So traditional concrete, as you can see, does not mimic any normal coastline habitat. It has a smooth surface. Most of the marine infrastructures are made of this material. It is the second most consumed material on Earth after water, and it's responsible for 8% of the global CO2 emission. So to look at this problem of coastal hardening and the big amount of concrete that is actually being spilled into the ocean each year, eConcrete has decided to try and understand how to create a better environment through that concrete, because we understand that concrete is going to be put in the ocean for ports, marinas, coastal shoreline protection. So how we can do that thing better. So we started with trying and understand if the composition of the concrete that is known to be damaging to the marine environment, can that be changed? Or is it just the texture that we can change and increase biodiversity? So we checked different material compositions, and we tested them with the texture and without the texture, and also tested it through different marine environments, from temperate seas to tropical lakes, practically in any place that there are concrete constructions in the sea. After 2 years of putting those different compositions in the water, monitoring them constantly, taking back to the lab, and also engineer tests through the entire experiments, eConcrete has a technology and now is the only environmental concrete technology that actually complies with the marine construction standards that are actually higher than standards on land. It needs to be stronger than it is. And we provide a biological and financial benefit. So our patent is actually based on 3 elements. We change the material composition, and it actually encourages the recruitment of different marine larvae. We change the surface complexity from a smooth complexity, mimicking a bit more natural rock, and macro design that supports the growth and survival by mimicking different habitats that we have in the marine environment. We tested these different projects that we have through, I think the longest project is already 10 years in the water. We can see that we increase the biodiversity and the percentage of live cover. We increase the species richness and abundance. We reduce the invasive species amount compared to native species. We recruit more inorganic biomass, and by that we increase the carbon reduction. And we significantly increase the water quality through filter feeders. The structural performance has been tested throughout, and we got validated, and actually the fact that we recruit more inorganic biomass, that causes the bioprotection by the calcium carbonate species that sit on our structures. Not only it makes it stronger, it also prevents the chloride penetration and also the cementous leakage. Throughout most of our projects, we continue testing, and our results are actually measurable. So we have numbers for each one of our projects. We're around the world, different seas, different location. different kind of solutions that we have for different kind of problems. Many of them are connected to climate change because of the increased storminess and the increase in population growth across coastal areas. So many of our solutions are for shoreline protection. We started with small pilot projects. This one is here in Marina in Herzliya. You can actually see that a few years after, there's an entire live cover of our structure, and it does not stand out as something artificial and actually gray in a dead zone. We continued through a big pilot project with the Monaco government and their environmental department. Again, continued monitoring it, saw much more species, biodiversity and richness on our structures compared to the artificial riprap structures that they have. We started with big projects now that are going to be throughout marinas, breakwaters. We are able to implant our technology in different kind of structures. Many of the designs we design ourselves, and sometimes our clients come and say, we need a structure this size, and we actually change that structure to comply more with the environment. This is a marine mattress that was needed in Shark River Island because the shoreline is actually eroding. We were able to create a marine mattress instead of just what they usually and sometimes do, just pour concrete, and nothing can actually grow. So this was, we had a experiment for 1 year. You can see it here if it will work. So on the left side is our structure, and on the right side is standard concrete. This was 1 year, a mattress made of 2 compositions, 1 year in the water. After 1 year, we took it out. This is how it looks when there's e-concrete technology compared to the standard Portland concrete. It was implemented in Shark Island. This is 2 months after installation. We started working with many ports. Many of them need us because of mitigation. We were part of the renewal of Port of San Diego, changing part of their riprap shoreline with our technology. This is our, it's called Coastal Lock. It's actually, if you change it in different orientations, it will create different habitats. So there's water retaining elements on the higher rows, and then when it's submerged in water, it's actually creating caves and different holes for different organisms that live there. This was monitoring 6 months after installation. Again, we saw much higher biodiversity on our structure, although the riprap was there for, I think, more than 15 years. But we still see more biodiversity on our structures. This is how the riprap control area looks like. Most of it is dominated by one invasive red algae. Compared to our structure, we have many more species of algae, and there's no one dominated species. That's one very important thing that we think is a bit overlooked, having not only more species, but not having just one dominant species on a structure. Now we're starting, I mean, it's already, soon it will be in the water, but there's a big project in front of Tottenville in Staten Island that was highly impacted by Superstorm Sandy, building 8 breakwaters and implementing our technology in the different areas and different kind of solutions that we have in the different areas of the breakwaters. This is right now being constructed and in the sea. In this project, the Living Breakwaters, we worked with the Billion Oyster Project, and we created oyster discs, which they planted oysters on and will connect to our structure. And then it can be a nursery also. We worked with the Trans-Adriatic Pipeline to create anti-trawling solutions for them to protect their cables. We started working with the port of Vigo that actually wants to change the port walls from being just concrete into our technology, which we're starting to test for also increasing biodiversity and also reduction of noise pollution, which is a big issue in ports around the world. Different marinas, specifically in Europe and the US, are changing their structures to be more ecological and working with us. Slowly, we're starting to work with the offshore industry. Offshore wind farms, a big wind structure in the middle of the ocean. It actually needs to be, first of all, anchored to the sea bottom, and then there's scour protection units around it. So one of the biggest companies in the world, Van Oor, that works on offshore structures, have actually tested our technology without us knowing. They validated it for recruiting much more than other construction material. Also, the environmental department, both in the Netherlands and the US, have also validated our technology to be the one to be implemented when building new wind farms. In the company, we're constantly continue researching and monitoring our products and trying to become more and more ecological. And because we're a company, also financial worth for the clients. Each one of our projects, at the end, we have a peer-reviewed manuscript submitted. And we're actually working together, engineers, designers, and biology, to improve the structures in the marine environment. Thank you.
Let me just repeat the question. Regarding pipelines, why is eco-concrete better than the traditional method?
So the traditional method, again, when it's concrete, we're coming to change the concrete that is already being used into our technology. So until now, there's or anchoring the pipelines with mattresses. So they or can use our mattress to anchor the pipelines, or what I've shown here, it was against trawling. So instead of just putting a big bulk of concrete, you put in a different kind of concrete. It's exactly the same volume of concrete, but our concrete is actually being manufactured with many recyclable materials. So that also reduces the carbon footprint of the concrete that is already being used. What?
How does it, wow. How does it compare, the eco-concrete, how does it compare cost-wise? And what's the main incentive for companies to use your product? I mean, it sounds like it's policy that's driving it, right?
Yes, so the main incentive is always policy and mitigation, because usually we're not being approached by the constructor, we're being approached by the company who wants to build a different breakwater, port, marina, or even shoreline protection for your own house. And in different countries, let's say the US, you need to pay mitigation the minute you put something in the water. So the incentive is to use us, which reduces the mitigation cost, because we increase biodiversity, reduce carbon footprint, and there's no other, I mean, we're facing against, our only competitor is standard concrete for now. It's a bit more expensive, but it was tested for the lifespan of it, and it's longer, so there's less, yeah. Yes. Thank you.
Thank you, Yaeli. I think Concrete is a wonderful example of a company that encompasses many different aspects of sciences and the industry together to create a positive outcome for our environment. Our next speaker is Mr. Arik Rosenblum from EcoOcean. Arik is a lawyer by training, but has been the director of EcoOcean since 2015. EcoOcean is a nonprofit Israeli organization established by the Whale family and a group of leading scientists and environmentalists in 2002. The organization's mission is to empower people to care for the marine environment and coastal environment of Israel and the region through research, education, and civic engagement. Thank you. Let me get your...
So I'm going to talk about a true force of nature. And that true force of nature is a force that's capable, on one hand, to create life, but on the other hand, to be able to make life unbearable. I'm pretty sure you know who I'm talking about, humanity. We're, as an organization, trying to get the majority of people to understand the issues that are at hand and to take a stand and to do something. So we're dealing, among other things, on how to beat the climate change blues. And when we talk about that, we have to remember people are being bombarded by scenes from around the world, and sometimes in their backyard, about calamities, catastrophes of enormous proportions, of vast fires, of flooding, of all kinds of situations where they're trying to understand what they're seeing, and on the other hand, many people are reacting in many different ways to the bombardment that they're being exposed to. What we've seen is there are three main ways in which people have been responding to the story of global warming. And look even at the wording, global warming, climate change. You know, people choose wordings in order to make it gentler or more accurate, and it's an issue because what we're seeing is there are at least three main responses to what people are doing when they hear or confronted with something to do with global change. So the first one is a great one, commitment. They get it. Okay, something's bad is happening. I have a chance to be a part of the solution, and this is what I'm going to do. And in many cases, it's very simple things. I'm going to, for instance, not buy single-use plastic and not use it. I'm going to recycle. I'm going to do all kinds of things that I should do. Others will volunteer for organizations, be on beach cleans like we conduct, and all sorts of other things. Other people may even create an NGO that will try to make some change on a national level or lobby or do other things in order to make that difference. That's where we'd like people to go, to be on the side of commitment. But there are two other groups that we have to deal with. And the two groups are, one, the deniers. Now, I want to suggest to you to give up on the deniers that completely deny climate change, global warming, whatever you call it. You can't change them. Any of you have tried doing it by posts or discussions around the dinner table. I think you've reached the same conclusion that I have. It's just not one of those things that work. They're not the group that I'm worried about. The group that I worry about is something that comes from what I think we're all existing in, and that is a a click-bite society. People, when they see something that they're not comfortable with, they will tune out, they will change the channel, they will swipe the screen and move on. And that's the denier that we have to try to find some way in order to talk with, reach, and get them to understand what needs to be the actions that they should take. But there's a third group, and it's a group that's really important for us to deal with. The American Psychological Association, for instance, did a study which discovered that 68% of the American public has some level, from very basic to extreme, sense of eco-anxiety. Now that eco-anxiety is happening not just in America, it just hasn't been studied in other places. I've been talking now with the Ministry of Education in Israel, and the Ministry of Education in Israel is bringing in Shefi, which is the group that deals with psychological work for children, into the school system because of the issue of how it's impacting children and youth. And by the way, the study in the States and the things we're beginning to see in Israel is that the situation with youth and children is worse. We're not just seeing a situation of despair, or we're seeing a situation that people are angry, that youth and children are angry. They're angry with the adults, the supposed responsible adults that were supposed to give them a world that they can live in and thrive. And on the other hand, what they're getting is a world that everyone's telling them is about to collapse. So having those three reactions, what we're dedicating ourselves to is to try to get people into the session, into the direction of commit. So I'm going to just say a very little bit about ourselves and then try to show you what is our motto of working and how we're trying to do it on the ground. So we're a small NGO called Echo Ocean. We have three arenas of work. One is that we're the only NGO in the state of Israel that runs a research vessel. And I'm proud to say that I think there isn't a marine biologist in the state of Israel that hasn't thrown up on our ship at some point in time on their way to try to get to further their career in marine biology, in geology, and in other studies. The second thing is education. We're a firm believer in education. Today, even with the corona situation, we were able to maintain about 25,000 children, youth, every year going through our programs in which we try to not just do a tidbit here, a tidbit there, but a whole program. And the third group is people, groups, communities, and trying to get them, just like we want an individual to understand they need to commit, we want cities to understand they need to commit. We want schools to need to commit. We want youth organizations and other groups to commit, and we're dedicated to that. So when it comes to what is our theory of change, our theory of change is positive activism. We don't demonstrate. We don't lobby in the Knesset. We don't go to court on issues. There are fantastic NGOs in the state of Israel that do that. We're coordinated with them. There's no need for us to hire lawyers and to bring lobbyists when other organizations have those people. What we try to do is to find things that need to be pushed forward and that are not happening. And by moving something forward, we hope that that is creating an energy that will make a change. And we agree or believe in three concepts that work separately, but work even better when they're together. So the first one is experience. So when we talk about the subject of nature and what's on the coast, of hiking in a mountain, and if you just add to that an educational component and an activist component, you've got a winning combination. And the second element is we have to admit we're not in a very popular group today. We're a bunch of people that believe in facts. And we know that it's not very popular today. And we believe that if you study something and you identify the problems, just like the day has been spread out today, where we're looking at problems, we're trying to find solutions, we think and we believe that that's the way to go, and we want to bestow those tools on anyone that's looking at the issue of climate change, of global warming. And when we go beyond that, we're also saying, do something about it. The best antidote in our minds to despair is to give people something to do, to show them they're not alone in what they're doing, and to show them that there even can be some results that come out of what they have been doing. So what I'm going to be doing with you now is to show you a bit of how we try to take this practice into our work, but of course it's just our examples. So the first is okay, oh, no. Let's go back. Another one before. Yeah. Thank you. So the first one is, as I mentioned, we have a research vessel. So we have a research vessel that we brought into the country in 2004. And it basically was brought into the country at the request of scientists. They were saying that so much effort, that we want to study more about the sea, but there's really no tools in our hands to do that. And the easier method to study the sea was to go to the Red Sea, to get scuba gear, and to go into the water and to see what's going on there. The Mediterranean, the Eastern Mediterranean, was considered murky waters with nothing of real consequence there, which allowed our politicians and allowed companies to be able to say, okay, then we can do whatever we want there. And that is something that we've been trying to change by bringing our ship into place. And that ship, by the way, we sponsor and we subsidize a lot of research through our ship. Now, this is actually an example of just one slight thing that was found by trying to study the territorial waters of the state of Israel and across the Eastern Mediterranean, and 10 kilometers out at sea, outside of Herzliya. And this is just an illustration, because I don't want to show you the real place, because then you'll go and try to do something about it, and we don't want that, is a rock. And on that rock is a sponge. And that sponge is now being researched as a cure for Alzheimer's disease. Now, I'm trying to take this example because I could tell you about biodiversity and how important it is for nature and all that, but I'm going to use the tools and the messages that sometimes we need to talk that talk in order to convince politicians and other people to understand where we're coming from. It's for your good, humanity. It's not just for nature. It's for you. If this site, if we can protect it from oil rigs and cables and piping and nets from fishermen, then we have a chance of making our lives better. And so that's what pushes us every day in order to do more and more in protecting the community, the nature. And the second is we use that same ship for education purposes. Just a week ago, we took 40 classes from throughout the country on a virtual visit to our research vehicle, our research vessel, to follow researchers in real time and to ask them questions and to make comments and to have a whole conversation with them about what's going out at sea and what can be found there. And one of the beautiful things about it is, even during the COVID crisis, when the kids were trapped in the Zoom cages that each of them were in, there was a chance, it's true, it's not real nature, it's visuals, but it was a chance for them to look outside of that box, look outside of their home for a second, and see the wonders of nature and say there's a lot of fascinating things out there. So these are things that we're trying to push further, and that's why when it comes to education, which is our second arena of work, we use every tool in the book in order to try to convey to children from kindergarten till 12th grade to senior citizens the story of the sea. What's out there? How is human activity affecting the sea? What can we do